In this video we're going to solve some questions on one-to-one functions. So we have a question here asking us to show that the following functions are one-to-one. So without wasting much of the time, let's start with the first one. So we have f of x is equals to 2x minus 3. Now a function is one-to-one if, let's say, function a, which is equals to function b. Therefore, if I cancel these ones, I can also say a is equals to b. So when a is equals to b, then those functions are one-to-one. Okay, one-to-one, that just means that each value of x is mapped to some value of y. Let's say this is the domain and this is the range. So I can have 1, 2, 3, then I can have a, b, and c. If the relationship between these ones is like that, where each element of x is mapped to some element of y, that is a one-to-one function. So basically, how do we prove that? Let's start with the first question. So to solve our first question, I'm going to say f of a should be equals to f of b to show that it is a one-to-one. Therefore, what I'm now going to do is that where there is a, where there is x, I'm going to be replacing a, then I equate it to b. Wherever there is x, I'm going to replace these two letters. So let me start with the first one. So I'm going to have 2. Where there is x, I'm going to put a. So 2a is minus 3 will be equals to f of b in this case. So I'm going to have 2b minus 3. Then from here, we just have to now solve. So I'm going to have 2a minus, okay, it's equals to 2b. I'm going to have negative 3 this side. Then this negative 3, when it goes to the other side, it becomes a positive. So I'm going to have positive 3. Then now I'm going to have 2a is equals to 2b. This negative 3 and positive 3 are going to give me a 0. Therefore, now when I reach here, I can divide the 2 on both sides. So I'm just going to remain with a is equals to b. So this one is a one-to-one function, the first one. Okay, let's solve the second one. So for the second one, we have f of x is equals to x plus 7 over 4. So we're going to do the same. I'm going to say f of a should be equals to f of b. In this case, I'm going to have a plus 7 over 4 should be equals to b plus 7 over 4. Then from here, I'm just going to now cross multiply. So this 4 is going to multiply with a plus 7. Then this other 4 is going to multiply with b plus 7. So allow me to write on my right hand side. So let me start with the 4 multiplying with a plus 7. So 4 multiplied by a, that is 4a. 4 multiplied by 7, that is a 28. This will be equals to, I come to the other side, 4 multiplied by b, that is a 4b. Then 4 multiplied by 7, that is a 28. So plus 28. Then from here, I just need to put the like terms together. Therefore, I'm going to have 4a is equals to 4b plus 28. When I take the 28 to the other side, it changes the sign. It's going to become negative 28. Therefore, I'm going to have 4a is equals to 4b. Then positive 28 and negative 28, they give me a 0. Now I'm going to divide by 4 on both sides. Okay, so the 4 and all the 4s are going to cancel. So our final answer is just going to be a is equals to b. So Roman numeral 2 is also a one-to-one function. Okay, we come to question number 3. We have f of x is equals to the square root of x. Okay, So in this case, we're going to say f of a should be equals to f of b if we are to show that it is a one-to-one. Therefore, now I'm going to have the square root of a is equals to the square root of b. For me to remove the square roots, I'm going to square on both sides. So this will be squared, this will be squared. Now that I've got this, the square and the root are going to cancel. I'm going to remain with a is equals to, even though on the other side the square and the root are going to cancel, I'm going to remain with b. So this one is also a one-to-one function. Let's solve b. Let's solve 5. So for 5, we have f of x is equals to 1 over x plus 2. Okay, we're going to do like the previous one. F of a should be equals to f of b. So let's try if it's going to give us a one-to-one function. So I'm going to have 1 over x plus 2, not x plus 2. I'm going to put, it's supposed to be a plus 2 will be equals to 1 over b plus 2. Then since I've got that, I'm just supposed to now cross multiply. So the 1 is going to multiply with a plus 2, then also the 1 is going to multiply with b plus 2. So what are we going to have? When the 1 multiplies with a plus 2, I'm just going to have a plus 2. This will be equals to, when the 1 multiplies with b plus 2, I'm just going to have b plus 2. Now that I've got this, I can take the 2 to the other side and to change sign. Therefore, I'm going to have a is equals to b plus 2 minus 2. Therefore, a will be equals to b. The 2, the positive 2 and the minus 2, they are going to give us a 0. So we're able to see that we have a is equals to b, which is also a one-to-one function. Okay, so let's solve question number 5. We have f of x is equals to 4 minus x squared, where x is greater than or equal to 0. So in this case, we've been given the domain. Okay, so now what are we going to do? We are going to do the same. So I'm going to say f of a should be equals to f of b. Okay, in this case, I'm going to have 4 minus a squared should be equals to 4 minus b squared. Then we solve. So if I take the 4 to the other side, I'm going to have negative 4. So therefore, I'm going to have negative a squared will be equals to, I'm going to write this 4 first. So I'm going to have 4. When this other 4 comes to the other side, it changes the sign and it becomes negative. So I'm going to have minus 4. Then I'm going to have minus b squared. Now that I've got this, what do we now do? I'm going to have negative a squared will be equals to 4 minus 4, that is a 0. Then I've remained with negative b squared. Therefore, I'm going because of this, I'm now going to divide by the negative on both sides. When I divide by the negative on both sides, I'm just going to remain with the a squared is equals to b squared. Since we don't want a square, I'm going to square root on both sides. So when I square root here and then I square root there, the root and the square are going to cancel, so I'm going to remain with a. The root and the square are going to cancel, I'm going to remain with b. So this is a is equals to b. Now if we're going to look at the domain, we've been given that our answer should be greater than or equal to 0. Okay, so it means we shouldn't have a negative number. Okay, we only want positive numbers for a and b. Okay, so basically that. So if you're going to be replacing your numbers in here in your function, you're only getting numbers that are greater than 0. So you're starting from 0 or greater. So for example, I have f of x is equals to 4 minus x squared. So I'm going to say 4 minus, let's start with 0. 0 squared will be 0. Therefore, I'm just going to have a 4. Then let's say I now go to any number that is greater than 0. Let me say 1. 1 squared if we say 1 squared, that is 1, we're going to get 3. Okay, then let's say 2 squared, that is a 4. Okay, 4 minus 4, that will give us a 0. Basically those will be our answers. Now we come to the last question. So for the last question, we are saying f of x is equals to x to the power 3 plus 1. So for it to be a one-to-one, f of a should be equals to f of b. So in this case, I'm getting f of a, so therefore I'm going to have a to the power 3 plus 1 should be equals to b the power 3 plus 1. Then we solve. So a to the power 3, when the 1 goes to the other side, it becomes a negative. Okay, so I have a to the power 3 is equals to b to the power 3. Okay, and the 1 and the 1, they're going to just give us a 0. So for us now to remain with a and b, what are we going to get? So we're going to get the square root, the cube root actually, the cube root on both sides. Okay, so the cube root and the cube like that, they're going to cancel. So I'm going to have a is equals to, so the cube root and the cube are going to cancel. I'm going to remain with b. So this will be our final answer. So basically that. So this is also going to be a one-to-one. Now, however, I would want to make mention also that for the previous one that we solved, we had a squared is equals to b squared, and we had to square. These ones had to cancel like that, and we had to remain a is equals to b. Okay, so for this one, okay, this one was fine. I think for the third one, okay, for the third one is also the same. So basically that I wanted us to have a scenario where if I've got a is equals to b, then that scenario requires us to find the square root on both sides. Okay, not really that the square and the root cancel, but to just find the square root. So you know that we're going to get positive or minus, a is equals to positive or minus b, right? So now because of this, this wouldn't have been a one-to-one because it's giving us several answers. Okay, so I thought of mentioning that. So basically this is how we show that a function is one-to-one. Thank you. Don't forget to subscribe, and we're going to see you in other sessions. In this video, we're going to solve some questions on inverse functions. So now we've been given to find the inverses of the following functions. So without wasting much of the time, let's start with the first one. So wherever there's f of x, I'm going to be putting y. So this will be y is equals to 12 minus half of x. Then in this case, I'm supposed to make x the subject of the formula. So what am I going to do? I'm going to have y. I'm going to take the 12 to the other side. I'm going to have negative 12 will be equals to negative half x. Okay, now for me to remain with x on this side, what am I going to do? I'm going to multiply it by negative 2 over 1 on both sides. Negative 2 over 1. So what do I now have? The 2 and the 2 can cancel. Then the 1 multiplied by the negative 1, that is just a 1. A 1 multiplied by x, that is just x. So we remained with x here. X is equals to. Then this side we've got a negative 2. Negative 2 is multiplied by y minus 12. Now when we multiply, I'm going to have negative 2y plus 24 is equals to x. So this is our answer. Now what I'm now going to do is that where there is x, I'm going to put the f inverse. So I'm going to put f inverse of x will be equals to, then I'm going to have negative 2 Where there is y here, I'm going to put x. So I'm going to put x plus 2, 4. This is the inverse for the first function. Let's solve for the second one. Okay, this time around we have f of x is equals to that. So I'm going to say y is equals to 1 over 2x minus 3. Then what we're going to do is that, allow me first to expand it in advance. So I'm going to have y is equals to 1 over 2 multiplied by x. That will give us a 2x. Then the 2 multiplied by the negative 3, I'm going to have negative 6. Now that I've got this, I'm going to now cross multiply. So the 1 multiplied by 1 on that side, I'm just going to remain with 1. Then the y is going to multiply with 2x minus 6. Okay. So what do I have? I'm going to have 2xy minus 6y. Then what I'm going to do now is I'm going to now factorize the y. So we've got 2xy minus 6y is equals to a 1. If I factorize out the y, what am I going to have? I'm going to have y. Then I'm going to have2x minus 6 is equals to 1. Then I'm going to divide by the y on both sides. Okay, so I'm going to have 2x minus 6 is equals to 1 over y. Now for me to remain with my x, now I'm going to take the 6 to the other side. What am I going to have if I take the 6 to the other side? So allow me to wrap this part. So I'm going to have 2x is equals to 1 over y plus 6. Then now for me to remain with for me to cancel the 2, I'm going to multiply by half on both sides. So this side half, even this side half. Therefore the 2 and the 2 are going to cancel, x therefore b equals to, when the half multiplies with everything that is in the bracket, what do I have? I'm going to have 1 over 2y plus 2 into 6, that is a 3. So I'm going to have a 3. So basically that. Then wherever there is x and y, I'm supposed to replace. Where there is x, I'm going to put the inverse. So I'm going to put f inverse of x. In this case, it's going to be 1 over 2. Where there is y, I'm going to put x plus 3. Okay. So basically, this is how we're going to solve this one. However, I wanted to try something else, another method, if it's going to work. F of x, okay, let me put y is equals to 1 over 2x plus 3, minus 3 actually, minus 3. So y will be equals to 1 over 2x multiplied by 2x minus 6. Now that I've got this, I'm going to cross multiply. So I'm going to have y multiplied by 2x minus 6 is equals to 1. Therefore, I'm now going to divide by y on both sides. So see the difference? Y and y are going to cancel. I'm going to remain with 2x minus 6, which is equals to 1 over y. Okay, then the negative 6 goes to the other side, it becomes a positive. So when it goes on the other side, I'm going to have 2x is equals to 1 over y plus 6. Okay, it is the same like the first one that we just solved. Okay, so basically that's how you solve for the inverse. Let's solve question number 3. So for question number 3, we have 2x. So y is equals to 2x plus 1 over 5. Okay, so for us now find, I'm going to cross multiply. I'm going to have 2x plus 1 is equals to 5 multiplied by y, that is 5y. Then I'm now going to make x a subject of the formula, so I'm going to have 2x is equals to 5y. When the 1 goes to the other side, it becomes a negative, so I'm going to have negative 1. Then for me to remain with my x, I'm going to divide by 2 on both sides. Therefore, that is x is equals to 5y minus 1 over 2. Then for it to be the inverse, where there is x, I'm going to put f inverse of x. So I'm going to put f inverse of x will be equals to 5. Where there is y, I'm going to put x. So that will be x, 5x minus 1 over 2. That will be the inverse. So the inverse always reverses the output. To show you what function did we input for us to get the output. So it reverses the output. Okay, so that's how we solve that one. Let's solve the last question. So we have f of x. Where there's f of x, I'm going to put y. Y is equals to 7 minus 3x over 10. Okay, if you've got this, I'm going to cross multiply. So I'm going to have 10y will be equals to 7 minus 3x. Okay, for us to remain with our x, I'm going to do something very crazy here. I'm going to take the negative 3x to the other side. Then at the same time, I'm going to bring the 10y to the other side. So when the negative 3x goes to the other side, becomes positive 3x is equals to 7. When the 10y comes to the other side, it becomes negative 10y. Now for me to remain with my x on the other side, I'm just going to divide by 3 on both sides. Okay, therefore now our it will be x is equals to 7 minus 10y over 3. Now what do we now do? We now have to introduce the aspect of the inverse. So I'm going to say f inverse of x will be equals to 7 minus 10. Where there is y, I'm going to put x over 3. So basically this is how you solve and show inverses. In this video, we're going to solve some questions on even, odd, and neither functions. Now just the basics before we start solving. The formulas that we use are going to be different. So for an even function, if you have f of negative x, this will be equals to f of x. This is for an even function. For an odd function, f of negative x will be equals to negative f of x. This is odd. Then a neither function doesn't satisfy any of these conditions above. So basically that. Now we have been given questions here. So we're saying the following functions. Are the following functions even or odd or neither? So basically those are questions. So allow me to wrap this part. Okay, so let's start. We have f of x. Now where there is x, I'm going to put negative x. So f of negative x, this will be equals to, wherever there is x, I'm going to be putting negative x. That's what this means. So I'm going to have negative x to the power 3 over negative x to the power 4 plus a 1. Then I just have to solve. Negative x to the power 3, that will it will give us negative x to the power 3 over then x, negative x to the power 4. That's like you have negative x multiplied by negative x multiplied by negative x. These ones are going to give you positive. These ones are also going to give you positive. Positive multiplied by positive, that will give you a a positive. So basically we are going to have x to the power 4 down plus a 1. Okay, now if I factorize the negative, is it going to work? Okay, so this is not even. Okay, why is it not even? Because look at our function. Our function, it is x to the power 3 over x to the power 4 plus 1, but this one, it has a negative, so because of that it is not even. So because it's not even, you go further to confirm if it is odd. So if it is odd, what are you going to do? Factorize out the negative. So if I factorize the negative, it will be negative. Then I'm going to have x to the power 3 over x to the power 4 plus a 1. Okay, now we're able to see that for an odd function we said it is f of negative x is equals to negative f of x. Now look at where f of x is and compare. So our f of x is here and our f of x this side is this expression. This expression is just the same as this that is in the brackets. So because they are the same, that is f of x. However, we have a negative in front. That just signifies for an odd function. So basically the first one is not an even function, but it is an odd function. Okay, now we come to question number. We have g of x. So g of x is equals to x to the power 4, x to the power 3 plus 1. Okay, so we are saying g, in this case I'm going to say g of negative x will be equals to, wherever there is x, I'm going to put negative x. So I'm going to have negative x to the power 4 over negative x to the power 3 plus a 1. Then I'm just supposed to solve. Now negative x to the power 4, that is x to the power 4, over negative x to the power 3, that is negative x to the power 3 plus a 1. Okay, this is what we have. Now if I may ask, is this the same as our original function? Is this the same as our original function? Okay, they are not, right? So this is not even. So because it is not even, what are we going to do? Let's try to check if it is it is odd. So I'm going to factorize the negative. So when I factorize, what am I going to? I'm going to have negative outside, or negative 1. Then I'm going to remain with x to the power 4 over x to the power 3 plus a 1. Okay, now if I factorize like that, is this going to work? No, I'm supposed to have x minus 1 like that. Yes, so that when we multiply by the negative inside, everything changes like that. But now, is this the same as for the odd function? So here you have a plus, here you have a minus, so this is not odd as well, so it's not odd. Okay, so since it's not odd, so this function is neither odd nor even. Okay, neither odd nor even. So neither odd nor even. Okay, so that is our answer for that one. Now we come to question number 3. We have f of x in this case I'm going to put it in advance. I'm going to put the negative in advance. F of negative x will be equals to, wherever there is x, we're going to be putting a negative x. So we have the absolute value of x, so I'm going to put negative x. This minus 1 over, we've got x squared, so I'm going to put negative x squared. Then I solve. Now the absolute value of negative x, every time you have a modulus, or what we call an absolute value, it always ends up giving a positive. Whether I have a negative, let me say I have the modulus of 2, that will give me a 2. If I have the modulus of negative 2, that will still give me a 2. Okay, so basically that. So in this case, the modulus of negative x, it will just be x minus 1 over negative x squared, that will just give us a positive x squared. Okay, so this is what we have. Now we've simplified it, and now the question is this function the same as our function there? Okay, is it the same? So of course it is the same. So this is f, so this means f of negative x is equals to f of x. So why are we saying the same? Because if we're going to just simplify this, it's going to be x minus 1 over x squared. This will be f of x, and this is what is, it's the same as this expression. So this is also an even function. So this is even. Okay, so that is how we solve those ones. So now let's solve these other ones. So for question number 4, f of, wherever there is x, I'm going to put negative x is equals to, so I'm going to have x, negative x, so I'm going to have negative x minus 1 to the power 3 plus, I'm going to have negative x plus 1 to the power 3. Okay, so this is a very long question. You just need to now multiply these ones. Okay, you need to multiply these ones. It's a very big number, of which I'm not going to do. So you're going to try this. So what you're going to do is that you're going to get negative x minus 1, multiply it with negative x minus 1, multiply it with negative x minus 1, plus, then you again try, you're going to have negative x plus 1, again negative x plus 1, again negative x plus 1. Then you find out like that. Quite a long one. Okay, let's solve v. So we have f of x is equals to x to the power 2 over 1 plus x squared. Okay, this is what we have. Wherever there is x, we are going to be putting negative x. So this will be f of negative x will be equals to, where there is x, I'm going to put negative. So in this case, negative x squared on top over 1 plus negative x to the power 6. Okay, so we solve. So f of negative x will be equals to negative x squared, that will just give us x squared, over 1 plus, now negative x to the power 6. So basically all even numbers, if you have a power of an even number, you're just going to get a positive answer. So in this case it is positive x to the power 6. Now that we've got this, is this the same as that function? Okay, so we're able to see that f of negative x is equals to f of x. So this is what? It's an even function. Okay, so that is how you solve this one. Now let's solve the last one. So for the last one, we have f of x is equals to the absolute value of x over x. Okay, what this means, wherever there is x, we put negative x. So I'm going to have f of negative x is equals to the modulus of negative x over x, or over negative x actually. Yeah, wherever there is x, we're putting negative x. Now, what I have on top, if I simplify it to remove the modulus, so f of x is equals to the it's just going to be x over x. X over x, that is just the 1, right? Okay, so let's also see if this one is going to give us the same as f of x. So if we're going to solve this, what do we have? We're going to have f of negative x will be equals to the modulus of a negative number, or even a positive number. It's just going to return the same number. In this case, we have x. The modulus of negative x will be x over negative x. Then if we divide these ones, x divided by negative x, that is a negative 1. So we're able to see that since x over negative x is not equals to our function, which is x over x, so this is not even. Okay, since it's not even, what about odd? Can it be odd? Let's try out. We're going to factorize the negative, so I'm going to have negative, then I'm going to have x over x. Okay, now that I've got this, I've got now f of negative x will be equals to, I've got the negative there, I'm going to write it negative. Then what I have in the bracket, x over x, is the same as f of x, which we are just coming from this direction, right? So it's the same as x over x. So I'm going to put just f of x here. So you're able to see that now your function looks like that after you factorize your negative. So basically this is an odd function. So this is how you solve questions and to prove whether. In this video, we're going to solve questions on finding the domain and the range of a function. So let's start. Find the range of each function for the given domain and state if the function is one-to-one or not. So basically, we've already been given the domain. Now, even just from the expression, you're able to tell that the domain is just the range of x values, your x values. Like for the first one, x is a member of real numbers, and x is such that x is greater than or equal to negative 2, but the same x is less than or equal to 4. So basically that. Now we're asked to find the range. Okay, now since they've already given us the domain, so we're going to use that domain to find the range. Okay, so they've already given us the x values. Now we're supposed to find the y values, which we're calling the range. So x, we're starting from negative 2. Then after negative 2, I can put negative 1. I can put 0. I can put 1, 2, 3, and 4. Now the question will be, in the function f of x is equals to, we are saying f of x is equals to x minus 2. In this function, if I replace negative 2, what value of y am I going to have as an output? So in this case, I'm going to have negative 2 minus 2. That will give me a negative 4. Okay, so I'm going to put negative 4 here. What if I put a negative 1? What do I have? I'm going to have negative 1 minus 2. That will give me a negative 3. So I'm going to put my negative 3 there. Negative 3. What if I have 0 here? What am I going to have? If I have 0 there, I'm going to have negative 2. What if I have 1? I'm going to have 1 minus 2. Y minus 2 will give me a negative 1. Then what if I have a 2 here? 2 minus 2 will give me a 0. Then what if I've got a 3? 3 minus 2, that is a 1. If I have a 4, 4 minus 2, that will be a 2. So able to see that numbers are reducing and going, we're moving from the smaller numbers to the bigger numbers. Basically, just a sequence, like negative 4, negative 3, negative 2, 1, then 0, 1, 2, and we're going that way. So able to see that the values of y are increasing, okay, from the negatives. Now, if I'm going to just illustrate this on a graph, how this looks like, if let's say this is our y-axis and this is our x-axis, then if I'm to just indicate, let's say the values of x, okay, negative 2, let me put negative 2 here, let me put negative 1 there. Then we got 1, 2, 3, and 4. Okay, then for y, y is going up to negative 4, so I'm going to put negative 1 here, negative 2, negative 3 here, let's say negative 4 is there. Then the highest value of y, let's say it's 2. Okay, basically this. Then I'm just supposed to plot this on the graph. So negative 2 is giving me negative 4. So if I'm going to plot that, negative 2 comma negative 4, it can be a point somewhere there. Okay, then negative 1 comma negative 3, negative 1 comma negative 3, it can be a point somewhere there. Then 0 comma negative 2, it can be a point where negative 2 is there. Then 1 comma negative 1, so it can be a point in this region somewhere there. Then 2 comma 0, it can be a point where 2 is exactly. Then 3 comma 1, it can be a point somewhere there. Then 4 comma 2, it can be a point somewhere there if I even put a 2 here. Okay, basically that. Now you're able to see that this is a straight line. If I'm going to join, you know, my points like that, so that will be my line, okay, showing that this is the function. Of course, joining all the points, you know, just the way they are. Now, what you're able to see is that since we've been given the domain, okay, we've been told where to start from and where to end from. So in this case, the range, which I'm going to call y, or the range of the function, in this case, the range of this function will just be equals to, it's going to be that y will be a member of real numbers, because it's a line. We want all the numbers in that line, okay? But however, because of the domain, we're just going to get the range itself from the smallest to the highest. The smallest value of y, we found was what? It was negative 4. The highest value of y we found is what? It is a 2. So therefore the range will be between negative 4 and 2. So you can put it in set interval notation like this, positive 2 like that. That is one way. Or you can put it as it will be negative 4. So y will be greater than or equal to negative 4, and this y will be less than or equal to 2, like that. That is another form of how you can show this range. So this is the range. Now, how do we now show that this function is a one-to-one? Because we've also been asked to find if it's a one-to-one or not. Now, the way we show that the function is one-to-one, you can watch some of our videos, but however, we're still going to solve. Okay, so if I've got a function f of a is equals to f of b, that is how we show that the function is one-to-one. In this case, it can be a is equals to b. So basically that. And if we're going to solve that, what are we going to have? So let me say I've got my f of a there is equals to f of b there. F of a, wherever there is x, I'm going to be replacing a. So in this case, since our question is x minus 2, I'm going to have a minus 2 will be equals to, then since we're comparing with b to be b minus 2, then I solve this. a will be equals to b, because when I take the negative 2 to the other side, I'm going to have positive 2. Okay, so I'm going to have this scenario. I'm going to have negative 2 plus 2, and this expression here gives me a 0. So therefore our a is equals to b. Now that our a is equals to b, we're able to conclude that this is a 1 to 1. 1 to 1 to mean that every value of x has got some value of y. All of them are paired. Okay, so what I mean is, if let's say these are the x values, these are the y values, I can have 1, 2, 3, then let's say a, b, and c. So if it's 1 to 1, all of them are paired like this. None of it is left, all of them are paired. Okay, basically that. So that's how we find the range for the first one. What about the range for the second one? So we have f of x is equals to x squared. Okay, so the domain, we've been given the domain. The highest value of y that you can have is, let's say, so this is x, this is y. Our function is x squared. Okay, so x, the highest value of x that you can have is, the lowest is negative 3. The highest that you can have is what? Is a 3. So in this function, I have to replace and find the values of y. So if I put y, if I put negative 3 squared here, what am I going to have? Negative 3 squared will just give me a 9. Then, what about 3 squared? 3 squared will also give me a 9. Okay, now since this is a quadratic, if I'm going to draw it just to illustrate, let's say this is our negative 3, then this is our 3 there. We've squared 3, it has given us this point. Let's say this is 9. We've squared negative 3, it has also given us a point on the other side as negative 9. Now we're able to see that if we're going to also pick a number between negative 3 and 3, the best one I can pick here is 0. Okay, if I say 0 squared, just give me 0. So I'm going to have 0, 0, let's say it's somewhere here. And therefore I'm going to join these lines. It's going to be something like this. Okay, now you're able to see that the values of y that we want, if this is a demarcation, okay, because the graph has turned at 0, 0, and that has gone again back where it was. So it is just all the numbers that are greater than 0. Okay, so basically, however, there's a domain. Okay, so in this case, the range for this function, yes, y will be a member of all real numbers, but now this y, it is between is such that this y is greater than or equal to 0, but this y is less than or equal to 9. Okay, because we're ending at 9. Okay, because that's where the highest value of x can have is at 3, which gives us a value of 9 there. So basically that, so like that. So this is how you show the range for the second one. Now showing that it is a 1 to 1, since our question is x squared, so if it is x squared, I'm going to say a is equals to b. Okay, in this case I'm going to have a squared is equals to b squared. Now if I'm finding a, I'm going to square this, okay, and I'm going to have that. So a will be equals to the root and the square are going to cancel. A will be equals to the square root of b squared. Whatever b squared is going to give us positive or minus an answer. Let me say positive or minus b. Okay, now the fact that we're getting two answers, one negative and one positive, okay, therefore we're able to see that there's a possibility that a can be positive b, and there's also a possibility that a can be negative b. So because one input value is giving us two output values, that is not a function, and because of that this is not a one-to-one. Okay, not one-to-one. That's how we show for the second one. Okay, let's solve the third one. So we've got f of x is equals to we're given 1 over x minus 1. So how do we solve such a one? So we've been given also the domain already. X is a member of real numbers and x is greater than 1. Okay, x is greater than 1. Now look at the way this is a rational function. It's a fraction. A function that is a fraction is called a rational function. Now because it's a fraction, in a fraction you don't want your denominator to be equals to 0. Okay, therefore the range, that's why we're getting all values that are greater than 1. We are trying to avoid a scenario where you can have let's say I have a 1 here as a value of x. It will give me 0 down, which will make the function undefined. So because of that, we want all the values of x, but we can put any number. Let's say you can put a 2 here. It will not make the function defined. But once we just put 1, it will make the function undefined. So if we're going to draw the graph, that part that is going to make the function undefined, we exclude it. So we're going to call it as an asymptote. We're going to call it as an asymptote. So let's say this is 1. Okay, so we're not supposed to touch that line. Then what do we now do in this scenario? Now if we get any number that is greater than 1, okay, and we put in the function, let's say I've gotten 2. If I put 2 there, I'm going to have 2 minus 1, that is a 1. 1 divided by 1, that will just give me a 1. Okay, now you're able to see that it's giving me a positive number. So because it's giving me a positive number, we are getting this region. Okay, then I come to the other side of 1. If I get any number that is less than 1, let me say a 0 here. Okay, if I put 0 here, 1 divided by 0 minus, so what are we going? We're going to have such a scenario as we have 1 over 0 minus 1. That will give us 1 over minus 1. 1 divided by negative 1, that is a negative 1. So because it's giving us a negative answer, it means it's going to come like this and follow the asymptote. Now you're able to see that it has cut this point. Okay, it has cut that point. So because it has cut that point, what is that point? That is the y-intercept. On the y-intercept, x is equals to 0. So because x is equals to 0, so if I'm going to solve this, it will be 1 over 0 minus 1, which will be 1 over negative 1. 1 over negative 1, that is a negative 1. So this point there is a negative 1. So this is negative 1, where it's cutting the y-axis. Okay. Now that we've got this, what can we conclude from this diagram? Okay. So you're able to see that we are getting all the values of y except 0. Okay. So in this case, y is going to be a member of, since the domain they've told us that x should be greater than 1. So in this case, we're only going to get numbers that not x should be greater than 1. So we're only getting these values that are in this direction of y. Okay, because those are the numbers that are greater than 1. Okay, so in this case we are moving all the way from 0 to negative to positive infinity. Okay, Okay, all the numbers that are greater than 1. So basically that. We've not included this part of the y because that part is not included in the domain. In the domain, we want x to be values of x should be greater than 1. Okay, basically that. So that's how we solve that one. Then we come to the other one. We've got f of x is equals to 1 over x squared plus 1, and they've given us the domain to be all real numbers. Real numbers, all the numbers that you can think about in the head, they are real numbers except complex numbers, but all the numbers are real numbers. Fractions, decimals, integers, negative, positive numbers, all of them are real numbers except complex numbers. So basically that is what we have. Now for the previous question, is it a 1-to-1? Let's try. Before I solve this one, we've got 1 over, it is x minus 1, so I'm going to say a minus 1 is equals to 1 over, I'm going to say b minus 1. Then we're going to cross multiply. A minus 1 multiplied by 1, that will give me a minus 1. That will be equals to b minus 1 multiplied by this 1, that will give us b minus 1. So a will be equals to b. So able to see that this one is also a 1-to-1 function. Okay, now we come to Roman numeral 4, this one. So we have a rational function again, but it has a quadratic down. Okay, it has a quadratic down, and we're saying x is all real numbers. So here we have to be very careful. Why? Because look at what we have. Every time you have a power of x that is greater than, that is, if your denominator on the powers of x is greater than what you have on the numerator, your vertical asymptote, in this case we have to find the vertical asymptote and the horizontal asymptote. If your denominator as the power of x is greater than what you have on the numerator, your horizontal asymptote is that y is equals to 0. You're not supposed to touch that line. Okay, basically that. Then for the vertical asymptote, get what you have on the denominator, x plus 1 is equals to 0. Then you solve this. Now x plus 1 is equals to 0. Since we're not interested in finding what the domain is, they've told us it's all real numbers. Any value of x that you can put there is going to exist. However, when it comes to y, that is going to be a very different case. Okay, so if I'm going to draw this graph, let's say this is the y-axis, this is the x, this is that's the y-axis, this is the x-axis. So this is x, this is y. Now where is our graph going to turn from? We're not supposed to touch y. We're not supposed to touch this part because that's the horizontal asymptote. However, if we're going to look at our graph, where is it going to cut the x-axis? It cuts the axis only at a point where it cuts at a point where x is equals to 0. On the y-intercept, x is equals to 0. So if I put 0 here, 0 squared plus 1, that is just a 1. 1 divided by 1, that is just a 1. So let me put, let's say the 1 is here. So it is cutting the y-axis at that point. Now what kind of a function is this one? It's a quadratic. So now we can tell the behavior of the function. So because it is x squared plus 1, the value of x in this case, it is negative. Okay, why I'm saying it's negative is because we have a 1 on top. Okay, a 1 is the same as a negative. If I've got 1, if let's say I've got 1 over 2. 1 over 2 is the same as 2 to the power negative 1, right? That is what that means. Okay, so now because of that negative, x is negative. Okay, and because x is negative, in this case we're going to have a maximum, right? So in this case our graph is going to either go like that. So it was supposed to go like this, going like that, but now we're not supposed to touch that line. So because we're not supposed to touch that line, it's going to go in that direction. Don't go in that direction. Now because it's going in that direction, I'm sure it's giving you a clue on what y, the values of y that you want. So we're able to see that we want all the values of y, but we're not supposed to touch 0. So the lowest value of y that you can have, you're able to see that it is 0. The highest value of y that you can have is the 1 there. Okay, 1. Yes, like that. So that would be the range for this function. So this is how we solve, these questions. Let's solve another set of questions. Now for this one, we're finding the domain. Find the domain and the range of the following functions. So unlike the first one where they'd given us the domain, this one we are supposed to find both. So let's find for a we're given f of x is equals to 1 over x squared plus 1. I think this is one of the questions that we solved. Okay, so in this case the domain for this function will just be all real numbers. Okay, there's no value of x that you are going to put here that is going to make the function undefined. Even if I put a negative here, it's just going to give us throughout we're going to have positive numbers down. Okay, what about the range? The range for this function is going to be, so for the range I think we also solved this one because I think it's just the previous question we're from solving. So we said we want all the values, y can be any 0, then the highest value of y that you can have is a 1. Okay, a 1 like that. So basically this is how the square. So without wasting much of the time, let's start with the first one. So the first question is x squared minus 10x plus 24 is equals to a 0. Okay, so in this case what am I going to do? I'm going to get the half of the coefficient of x, which is negative 10. So negative 10 multiplied by half, I'm going to have negative 10 divided by 2. Negative 10 divided by 2, that gives me a negative 5. So that is the half of that. So now what I'm going to do is I'm going to write x squared minus 10x the way it is. Then I'm going to add and subtract by the coefficient of x squared. Okay, so in this case what am I now going to have? I'm going to have plus, I'm going to have negative 5, I'm going to square it, then I'm going to again subtract it, the same one, then plus 24x is equals to plus 24 is equals to 0. Then from here what I'm now going to do is that I'm going to get these ones with the squares, I'm going to put them in one bracket, and then we are going to ignore the one that we've just halved. So I'm going to have x minus 5, then I'm going to put these ones in bracket, then I'm going to square. Okay, then we're supposed to now say minus, then 5 squared, that gives us a 25. Okay, so I'm going to have a 25 plus 24. This is equals to 0. Then from here I'm just supposed to solve. I'm going to have x minus 5, this is squared, then minus 24 plus 24, 25 which is negative and 24 which is positive. Because the signs are different, what is that going to give me? It's going to give me a negative 1. This is equals to 0. Then when I reach here, what am I now going to do? I can take the 1 to the other side. I'm going to have x minus 5 squared is equals to Since it's negative 1, when it goes on the other side, it's going to become a positive 1. Okay, now that I've got this, I can square root on both sides. So I square root this side and I square root that side. I'm going to have x plus 5 is equals to, the square root of 1 is positive or minus 1. So because I've written x plus 5, the reason is simple. The root and the square are cancelling. Okay, then the square root of 1, it is a positive or a minus 1. Okay, then what do we now have? What we now have is just going to be x minus 5. Actually it's minus 5, not plus 5. Okay, so I'm going to have x minus 5 is equals to negative 1, and the same x minus 5 is equals to positive 1. Then we solve. So x is equals to negative 1. When I take the negative 5 to the other side, it becomes positive. I'm going to have positive 5. Then x will be equals to negative 1 plus 5. That gives me a 4. Then on the other side, x is equals to, I'm going to have 1 plus 5. X will be equals to 6. So basically, these are the two solutions for this quadratic. Let's solve the second one. So for the second one, we have 2x squared plus 12x plus 5. So we're also going to do the same. What is the coefficient of x in this case? We have a 12. So we're going to find the half of that by multiplying by half. Now when we multiply by half, the half of 12, that is a 6. Okay, so now we're going to have 2x squared plus 12x. The 6 we're going to say plus, the 6 we're going to square it, then the same 6 we're going to subtract it, plus 5 is equals to 0. Then when we are here, what do? I'm going to do something different here. Okay, for this one, okay, since we have a 2 which is a coefficient here, always make the coefficient of x here to be 1. So basically I'm going to change the approach. I'm going to factorize the 2 outside. So I'm going to have this, I'm going to have x squared plus I'm going to have, when I factorize the 2, this will be 6x plus 5 over 2 is equals to 0. Okay, why we're doing this is because we want our equation to be in the form of ax, want it to be in the form a x plus p squared plus q, where your p and your q are your coefficient, then where your a is a coefficient, you know, of 2x, like in this case we have a 2, that's why I've put it outside. Then when you have this, now that's when you're supposed to half the coefficient of x, which is 6. Now the half of 6, that will just mean we're multiplying 6 by half, which will just give us a 3. Therefore I'm now going to take the 2 throughout. This side I'm going to have x squared plus 6x. Then we're going to add and subtract the half of 6. In this case is plus 3 squared minus 3 squared. Then we're going to say plus 5 over 2. Everything is equals to 0. So we're going to maintain the 2. Then since the x and the 3 in this case are squared, I'm going to put them in one bracket. So I'm going to have 2. So I'm going to have x plus 3. This will be in one bracket squared. Then minus, then 3 squared. 3 squared, that gives me a 9. Okay, then plus 5 over 2. Then I can find the common denominator here, which is 2. Here I put 1. 1 into 2, that is a 2. 2 multiplied by 9, that is 18. Plus 2 into 2, that is a 5. Okay, that is minus. Then I write everything 2 x plus 3. Okay, this is squared. Then I solve. I'm going to have 2 x plus 3. This is squared minus. Now 18 plus 5. What is 18 plus 5, what does it give us? So in this case it's going to give us what, 18. Oh, actually we're subtracting the 2 because there's a minus here. Okay, so 18 in this case we've got 18, then 5, that would be a 13 here over 2. Now that we've reached here, we're now going to distribute the 2 back. Okay, we're now going to distribute the 2 back. Now if I distribute the 2 back, what am I going to have? I'm going to have 2 x plus 3, this is squared, is equals to, or minus 13 actually, minus 13 is equals to 0. Why we're having that is because the 2 and the 2 on the other side are just going to divide. Okay, when we multiply it with the negative 13 over 2. Okay, then I wrap this side. Okay, now we've got 2x plus 3, this is squared, minus 13 is equals to 0. So basically that is what we have as our equation. What do we now do? I'm going to take the negative 13 to the other side, so I'm going to have 2x plus 3 squared is equals to, when the negative 13 goes on the other side, it becomes a positive, so I have a positive 13. Then I'm supposed to divide by 2 on both sides. Okay, when I divide by 2 on both sides, what do I now have? I'm going to have x plus 3, this squared is equals to 13 over 2. Now that I've got this, for me to remain with my x, I'm going to square root on both sides. So when I square root, the root and the square are going to cancel, so I'm going to remain with x plus 3 will be equals to the square root of 13 over 2. Okay, now that I've got this, what do? I'm just going to now say x is equals to, when I take the 3 to the other side, it becomes a negative, so I'm going to have negative 3. Then the square root of this, whatever it is going to give us positive or minus the square root of 13 over 2. So basically x now will be equals to negative 3 plus the square root of 13 over 2, or x will be equals to negative 3 minus the square root of 13 over 2. So basically this is how we solve this one. Let's come to question number 3. We've got 3x and that. Okay, so we're going to also do the sum. I'm going to factorize out the 3. So I'm going to have 3. I'm going to remain with x squared here plus 3 into 2 of that is a 4. Okay, 4x. Then I'm going to have 2 over 3 is equals to 0. We factorize out the 3. And then what I'm now going to do is I'm now going to find the half of the coefficient of x. We have 4. When you multiply by half, what are we going to have? The half of 4 is just the 2. Okay, so we're going to have 3. I'm going to have x squared plus 4x. Then since we have a 2 as a half of x, as a half of the coefficient of x, so we're going to have plus 2 squared minus 2 squared minus 2 over 3 is equals to a 0. So we're going to maintain the 3. Then we're going to ignore the one that we've halved. Then I'm going to put the x squared and the 2x squared and the 2 squared in one bracket. So I'm going to have x plus 2. This is going to be squared minus 2 squared, that gives me a 4 minus 2 over 3. Then I'm supposed to solve this. So if I put over 1 here, 1 into 3, that is a 3. A 3 multiplied by the 4 on top, that will give us a 12 minus 3 into 3, that is a 1. A 1 multiplied by the 2 on top, that is just a 2. Then I write everything 3 x plus 2, this is squared, Okay, basically this is what we have. Now if we solve this, what do we now have? I'm going to have 3, I'm going to have x plus 2, this is squared, then I've got negative 12 and negative 4. Actually negative 4 and negative 2, that is negative 14. Now that we've reached there, I'm now supposed to distribute the 2 inside the bracket. So when I distribute, I'm going to have 3 x plus 2, this is squared, minus 14. Basically, because the 3 and the 3 are going to cancel on the last side. Okay, so this is equals to 0. Then we have an equation for us. We now have to say 3 x plus 2 squared is equals to, when the 4 goes on the other, negative 14 goes on the other side, it becomes positive 14. Then I divide by 3 on both sides. So x plus 2 squared is equals to 14 over 3. Then for me to remain with my x, I'm going to square root on both sides. So when I square root on both sides, so the square and the root are going to cancel. I'm going to have x plus 2 is equals to the square root of 14 over 3. Then we're going to have x is equals to, the 2 is going to go on the other side. I'm going to have negative 2. Then positive or minus the square root of 14 over 3. What this means is that x is equals to negative 2 plus the square root of 14 over 3, or x is equals to negative 2 minus the square root of 14 over 3. Basically, these are the solutions. So this is how you complete the square of different equations that you've been given. So completing the square is usually a concept that we mostly use for graphing equations. Yes, mostly quadratic. So it's one of the good ones if you're going to find the intercepts and other concepts. So to even learn more about that, you can watch more of our videos on the same. Thank you, and we're going to see you in other sessions. In this session, we're going to solve quadratic functions. Specifically, this common question that usually comes almost in any exam. Okay, so how do we go about it? So we've been given a function. This is our function. And then we are told to solve by completing the square. Why are we trying to solve by completing the square? Because we want it to be in the form of a open brackets x plus p squared plus q, where these letters a, p and q are constants, meaning they are numbers. Then for b, we're told to state what the maximum is and the minimum point of the function. In this case, that is just the same as the turning point. Then we're also told to sketch the graph for this function. So how do we complete the square? So in case maybe you haven't learned how to complete the square, you can watch our videos. They are there on how we complete the square. So we have the negative 2x squared as our function, plus 2x plus a 1. So when you're completing the square, you want to make sure that the coefficient of the x squared, which is our a, it should be like 1. So in this case, I'm going to factorize out the 2 or the negative 2. I'm going to remain with x squared. When I factorize the 2 here, I'm going to remain with negative x. Here I'm going to remain with 1 over 2. Okay, this way expression is equals to 0. Now what I'm going to do now is equals to, I'm going to get the half of the coefficient of x. Now what is the coefficient of x in that regard? We've got, this is negative 1. So what is the half now of negative 1? So we're going to multiply negative 1 multiplied by half. So when we multiply negative 1 multiplied by half, I'm going to have negative 1 over 2. So I'm going to have negative half as the half of negative 1. Now what I'm now going to do is that I'm going to write my x squared minus x, then this what we have, I'm going to square it, subtract it and add it. So I'm going to have a plus, then negative half, I'm going to square it, at the same time I'm going to subtract it. I'm going to subtract it. So I'm going to put minus, then negative half there, squared. Okay, then we've got also this negative half, don't forget it. So I'm going to put negative half there. Okay, now that we've got this, I'm going to write my negative 2. Now I'm going to ignore the one that we've halved. The one that we've halved, it is negative x. Then I'm going to put the ones with the squares in one bracket. Okay, so I'm going to have x minus half, like that. This would be squared, minus, then I'll solve what is in the bracket. So negative 1 squared, that is a 1, over 2 squared, that is a 4, minus half. Okay, this is what I have. So I'm going to wrap this part. Okay, so we're going to remain with negative 2 x minus half, this is squared. My interest is negative 1 over 4 minus 1 over 2. So the common denominator is a 4. A 4 into 4, that is 1. 1 multiplied by the negative 1 on top, I'm going to have negative 1. Then 2 into 4, that is 2. 2 multiplied by the negative 1 on top, that is a negative 2. Okay, basically that. Okay, now when I add what is on top, negative 1, negative 2, that will give us a negative 3 over 4. Okay, so that is what I have there. Now if that is what I have, I'm going to put it here. So it's going to be, I'm going to have what? I'm going to have negative 3 over 4 there. Then when was square rooting this one, it was supposed to be positive 1 here. Okay, basically that. But at the end of the day, we're going to have, that is 3 over 4. Okay, let's say that is what we have. Now what do we now do? We are now going to, since this is what we have, okay, don't forget the square outside. I'm now going to distribute the 2 inside what we have in the bracket. So I'm going to have negative 2, that will give us x half, this is squared. Then the negative 2 multiplied by negative 3 over 4, that will give us positive 3. 2 into 4, that is a 2. So we're going to have that expression. So this is what we have as the final answer by completing the square. Now we're told to find the maximum and the minimum. The maximum and the minimum, these are the turning points, okay, where your graph is going to turn from. So the way you get it, it is P comma Q. Now your P is negative, you put negative P. That's how you find the turning point. Now what is the P and what is the Q? In this equation we've got P and Q. P is the value of x, Q is the value of y. Okay, however when you're getting a turning point, your P should be negative. Okay, you put a negative in front. So in this case our P, it is negative half. So because we have a negative in front, that negative is going to cancel, so we're just going to have half. Then our Q, you're just going to get it the way it is, which is 3. So this will be 3 over 2. So that is the maximum and the minimum of this function. Then the last one, we're taught to sketch the function. Okay, so now how do we sketch the whole function? Basically, you can also learn how we sketch them. You can watch our videos. So the way we sketch, we're supposed to find the intercepts. On the x-intercept, if we're going to start with the x-intercept, on the x-intercept, y is equals to 0. Okay, because y is equals to 0, I'm going to get the whole equation 0 equals to, now 0 equals to this whole expression that we've already at least calculated the reaching that far. So 0 equals to all this equation. Now this equation we've solved it until we've reached here. So therefore I'm just going to replace there and solve. So I'm going to have negative 2. I'm going to have x minus half there squared plus 3 over 2. Then what I'm going to do now is I'm going to take, which ones can I take on the other side so that we just remain with at least positive numbers. Okay, so I can take, so I'll take the 3 over 2 on the other side. So I'm going to have 3 over 2. Now this will be negative, right? Because it has gone there on the other side. This will be equals to negative 2 x negative, that is half 2. Okay, now that we've got this, for me now to remain with my this is what we have in the bracket, I'm going to divide by negative 2 on both sides. Okay, when I divide by negative 2 on both sides, okay, allow me to wrap this part. I'm going to have, this is going to cancel, so I'm going to have remain with x minus 1 over 2. This is squared is equals to negative 3 over 2. Since I was divided by 2. Every time you're dividing, it changes to multiplication, right? So I'm going to have multiplication, it will be 1 over 2. Therefore, this will be equals to negative 3 over, oh, don't forget this is a negative. Okay, so that would be negative 4. Now that I've got negative 4, this will just give me 3 over 4 on the other side. So that is what I have. Allow me now to rub this part. I don't want us to rub the actual equation. Okay, what have I rubbed? Okay, this part. Okay, so what we have now is we've got x minus 1 over 2 squared is equals to 3 over 4. So now for me to cancel the square, I'm going to square root on both sides. So the root and the square are going to cancel. I'm going to remain with x minus half is equals to the square root of 3 over 4. Now, so we have x minus half is equals to, actually I can take the minus half on the other side in advance. So for us to remain with x, I'm going to take the minus half on the other side. So I'm going to have, it is going to become positive half now. Then the square root of 3 over 4. So what this means is that, you know, from your sides, if I've got the square root of a number a over b, this can also mean the square root of a over the square root of b. Okay, then you solve. So even in this case, since we have 3 and 4, the square root of 3, we're just going to write it just the way it is. So to be positive or minus the square root of 3 over, then the square root of 4 down, that is a 2. So basically these are the answers that we have. Okay, so x, allow me to write them here. So x would be equals to positive half, or let me just write half, plus the square root of 3 over 2, or x can be half minus the square root of 3 over 2. So those are our two answers that we have. Now what about on the y-intercept? What are we going to have? On the y-intercept, x is equals to 0. So what that means is that in the equation I'm just to replace wherever there is x, I'm supposed to put a 0. So this is what we mean. Our equation is f of x is equals to negative 2. Wherever there is x, we'll be replacing 0. Squared plus 2, 0 plus 1. Then we solve. This will give us 0, this will give us a 0. A 0 plus 1, that is just a 1. So we're finding a point for the y-intercept, okay, to be at 1. Okay, so that point will be 0, 1. Okay, now that we found that one, now we have everything that we need to literally sketch the graph. Okay, so if I'm going to draw a simple graph, let me rub this part. I'm going to use this part for drawing the graph. So let's say this is our graph. Okay, so I'm just now supposed to put the points. So the points that we have, one of the points is 1, 0, 1. Let's say our 1 is here. Okay, so 0, 1 will be a point somewhere there. Or let me put it here somewhere there. Okay, good. Then the turning point, okay, that is no, I've put it on the wrong side. 0, 1 is here. Okay, somewhere, let's say our 1 is there. Then the turning point, let's say these are the two answers that we have. Okay, the turning point, we found that it was half, 3/2. So let's say our half is, let's say our 1 is here, half is somewhere there, the half of 1. So let's say it would be a point somewhere there. Then let's say this is like 3/2. That was our turning point. So that is our turning point there. Then where the graph is cutting the x-axis, we've got one that is positive and one that is negative. Okay, so the one that is negative, let me put it here, 1/2 minus the square root of 3/2. Then let's say it's also cutting it on the other side. That would be half plus √3/2. Now if we're going to join them, you're just supposed to join them nicely like that. Okay, so that is how our graph is going to look like. Basically, this is how we solve this type of a quadratic function. In this video, we're going to solve some questions on how you find the maximum and the minimum value of a function. So basically, these are some of the questions. So the minimum and the maximum value of a function is just the same as the turning point. Okay, so let's start with the first question. Now you can solve this using calculus. You can also solve it using completing the square, which we are mostly familiar with. You can watch our videos on how you solve using completing the square. Okay, however, there's another formula that you can use, which is x. If you're finding the value of x at the turning point, it is -b/2a. Then from here, just supposed to replace. That would be negative. B is the coefficient of x. In this case, it is a 6. So it is -6/2. Our a is the coefficient of x squared. That is a 1. Therefore, I'm going to have -6/2. -6 divided by 2, that is -3. So this is the value of x at the turning point. What about y? So for y, we're going to replace the value of x in the whole function. Okay, so therefore we're going to have f of, wherever there is x, we're going to be replacing by -3. So that would be f of -3 is equals to -3 squared plus 6, -3 plus 5. Then we solve. -3 squared, that gives us a 9. Okay, then minus 6 multiplied by 3, that is 18. plus 5. Okay, 9 minus 18, that is negative 9 plus 5. Negative 5 plus negative 9 plus 5, that will give us a negative 4. So that's a value of y at the so the turning point in this case will be equals to negative 3, which is the value of x, and negative 4, which is the value of y. That's where our graph is going to turn from. So basically this is how we're going to be doing for all the other questions. However, you can solve it also using completing the square, although maybe a bit it will depend on the route that you want to use, okay, based on how tedious the question is, because sometimes the numbers can be so big that you might not use this formula that we've used. So the way we complete the square, I'm going to say x squared plus 6x plus 5, this is equals to 0. Now I'm now going to find the half of the coefficient of x. Our coefficient of x here is 6, so I'm going to find its half by multiplying by 1 over 2. When I multiply by that, what am I going to have? I'm going to have 2 into 2, that is 1, 2 into 6, that is a 3. I'm just going to remain with a 3. So therefore we are going to have x squared plus 6x plus this half, okay, the one that we found. We are going to add it and subtract it, but by squaring it. So in this case I'm going to have 3 squared, okay, minus again 3 squared plus the 5. Okay, now that we got this, we just need to solve. Now what you're now going to do is that this one that we had halved, I'm going to ignore it. Then the ones with the squares, I'm going to put them in one bracket. So I'm going to have x plus 3, this will be squared, minus, now 3 squared here, that will give us a 9 plus a 5 there. So therefore our final answer, if we're going to solve, we're going to have x plus 3, the square, minus 9 plus 5, in this case negative 9 plus 5, that will give us a negative 4. Okay, so this is our answer. Why we are saying this is our answer? Because we always want our answer to be in the form of a x plus p squared minus let's say minus or plus q, just like that, plus q. So this is the form that we always want to attain when you are using completing the square. Now what you are able to see now is that for the turning point, based on this expression that we've written, the turning point will be equals to negative p comma q. So whatever you have as the p, put a negative in front. In this case, what is our p? From the equation you're able to see that p is here. Even from the one that we're from solving, p is here where 3 is. So we're going to put minus, then we'll put a 3, comma. Q, you're just getting it the way it is. The q in this case, it is our negative 4. So that is negative 4. So that is the turning point. Then verifying that this is equals to that. So depending on the method that you're using, yeah, you're going to solve using that. Then how you sketch this one, just find the turning points. We've already found the turning point. Just find the intercepts and you graph. Then you're done. So let's solve the second question. So we've got x squared plus x minus 6. So what are we going to do? X is equals to negative b over 2a. Then from there, we're just now supposed to solve. So that will be negative. Our b, it is the coefficient of x, which is 1 over 2. Our a is also 1. So we're going to have negative 1 over 2. So that is the value of x at the turning point. Then what about the value of y there? So the value of y, we're going to just replace by what we found as the value of x. That is negative half. That will be equals to, so we're going to have negative half squared plus negative half minus 6. Then we're just supposed to solve this whole expression. Now if I have a square here, So I have a negative 1 squared, that will just give me a 1, over 2 squared, that will give me a 4, then minus 1 over 2 minus 6. Okay, basically that. So let me just solve this equation. So we've got 1 over 4 minus 1 over 2 minus 6. I can put over 1 this side, and I find the common denominator, which is 4. 4 into 4, that is a 1. A 1 multiplied by the 1 on top is a 1. Minus 2 into 2, 2 into 4, that is a 2. A 2 multiplied by the 1 on top is a 2. Minus 1 into 4 is 4. 4 multiplied by 6 on top, that is a 24. Then we solve what we have. Now we've got negative 1 minus 2, that is negative 3. Negative 3 minus negative 24, that is negative 27. So we're going to have negative 27 over 4. Is it? Yes. So basically that. So at the turning point, therefore, we're just going to have what are we going to have? Okay, we are going to have what did we find as our x? Our x was negative half, comma, negative 27 over 4. So basically that would be our turning point. So let's solve the third question. So that is what we have there. So what are we supposed to have as our x? The same thing, x will be equals to negative b over 2a. We're going to have negative, what is our b? Our b in this case is 5. What is our a? Our a is 2. Then we solve. So we're going to have negative 5 over 4 as the value of x. Then for us to find the value of y, so to be f of negative 5 over 4 will be equals to 2. Wherever there's x, we're going to be replacing negative 5 over 4. So we're going to have negative 5 over 4. This is squared plus 5, negative 5 over 4, then minus 12. Then we just solve this, expression. So the 2 into 2, that is a 1. 2 into 4, that is a 2. So I've got negative 5 over 2. Oh, actually we have a square, so I'm not supposed to forget the square first. So I'm going to have a 2. 5 squared, because I have a square there, 5 squared, in this negative, I'm going to have 25 over 4 squared, that is a 16, plus 5 multiplied by the negative 5, that will give us a negative 25 over 4, then minus 12. Basically that. Now that we got this, we just need to now just solve this expression. So 2 into 2, that is a 1. 2 into 16, that is 8. So I'm going to have 25 over 8 minus 25 over 4 minus 12. Then I just find the common denominator. The common denominator here is 8. 8 into 8, that is 1. 1 multiplied by the 25, we have a 25. Minus 4 into 8, that is 2. 2 multiplied by the 25 on top, that is 100. Is it? Not a 52, that is. Okay, that is a 50. Okay, then minus 1 into 8, that is 8. Then 8 multiplied by 12. So 8 multiplied by 2, that is my 16, carry 1. 8 multiplied by 1, that is okay. So we're going to have 96. Okay, basically that. Then we're going to have over 8. Then we're just supposed to subtract 25 minus 50, that is negative 25, minus 96. Then you solve 8. Okay, so it will be 8 over negative 25 minus 96. That gives us negative 121. So basically that would be the value for y at the turning point. So basically this is how you find the maximum and the minimum of a function. Okay, either using completing the square or just normal using the formulas that we've been using. So thank you, and we're going to see you in other sessions. In this video we're going to solve some alpha and beta problems. So without wasting much of the time, let's start with the first question. So our question reads that the root of the equation 2x squared minus 4x plus 5 is equals to 0, and these are alpha and beta. Then we're told to find the value of the following equations. So starting with the first question, but before we even solve the first question, we've been given the equation 2x squared minus 4x plus a 5. This is equals to 0. So we're first supposed to find the sum of alpha and beta, which is alpha plus beta. Then you know that this one we find it by negative b over a. Then we're also supposed to find the product, which is alpha multiplied by beta, which is given by c over a. Now what is our c, what is our a, and what is our b? So our a in this equation, in this equation, a is equals to 2. Our b is the coefficient of x, which is negative 4, and our c is equals to 5. Now we're supposed to solve this equation. We're saying alpha plus beta is negative b over a. In this case, negative b, in this case our b is negative 4 over our a is 2. Then when we solve, we're finding that the negative and the negative will give us a positive, so it will be 4 divided by 2, which will just give us a 2. That is the sum. Then for the product, we've got c over a. Our c, we're saying it is 5. A is 2. So these are our answers. So we've got the sum alpha plus beta to be equals to 2. Then alpha beta is equals to 5 over 2. Okay, so basically that is what we have. Now that we've got this, we can now solve our equations. Okay, so let's start with the first one. Our a, it is 1 over alpha plus 1 over beta. So what are we going to do? For this one, we're supposed to look for the common denominator. In this case, it will be alpha beta. Okay, now if I divide alpha into alpha beta, I'm going to remain with beta. Beta multiplied by the 1 on top, I just have a beta plus. Then if I divide beta into alpha beta, I'm just going to remain with alpha. Alpha multiplied by the 1, I'm going to have my alpha. Now I can solve this as, you know that addition is commutative. If I say 1 plus 2, it's also the same as 2 plus 1, because I'm going to get the same answer. So even what I have on top, beta plus alpha, I can write it as alpha plus beta over alpha beta. Then from this, now I'm just supposed to replace. We found our alpha plus beta to be equals to 2. Okay, so I'm going to replace 2 here, divided by alpha beta. So I'm going to write a division symbol. Alpha beta, we said it is 5 over 2. Then we're just supposed to solve this. So I'm going to say 2. Every time you're dividing, it changes to multiplication. In this case, I'm going to have 2 over 5. Okay, those are going to swap. Then when we solve, 2 multiplied by 2 on top, that will give me a 4 over 5. So that is the answer for the first question. So that's how we solve the first question, which is this is equals to 4 over 5. Now we come to B. B, we are told to find alpha plus 1. This is multiplying by beta plus 1. Okay, so here we're just using the rule of expansions, nothing much. So we're going to get the alpha. It multiplies with everything that is in the bracket. We find our answer. Then we get our 1, we multiply by everything that is in the bracket. Then we find our answer as well. So in this case, what are we going to have? Alpha multiplied by beta, I'm going to have alpha beta. Then the alpha multiplied by the 1, I'm going to have alpha. Then I come to the other side. The 1 will multiply by everything that is in the bracket. When the 1 multiplies with everything in the bracket, everything in the bracket is just going to remain. So I'm going to have plus beta plus 1. Now that I've got this, I'm just supposed to, replace sequentially just the way we had. So we have alpha beta, which is 5 over 2, plus Then alpha plus beta, this one I can put it in the brackets. And when I put it in the brackets, what am I going to have? I'm going to have a 2 there plus a 1. Then my job is just to solve this equation. So I've got 5 over 2 plus 2 plus 1. So I can get the common denominator as 2 throughout. Okay, so the 2 into 2, that is a 1. 1 multiplied by 5, that is a 5, plus 1 into 2 is 2. 2 multiplied by 2, that is a 4, plus 1 into 2 is 2. 2 multiplied by 1, that is a 2. Then what do I have on top? A 5 plus a 4, that is a 9. A 9 plus a 2, that is an 11. So I'm going to have 11 over 2. That is our answer for B. We're saying this is 11 over 2. Okay, so that's how we solve B. Let's come to C. C is actually a rule. Okay, so if I've got alpha squared plus beta squared, this one is a rule that you're supposed to either memorize or know how it comes about. So we're going to have alpha squared, we're going to have alpha plus beta squared, okay, minus 2 alpha beta. So this is the one that you're supposed to use. You have to know this one. So you can watch our videos on the roots of a quadratic equation. You're going to find out how we come up with this equation. Now if we solve this, what are we going to have? We're just supposed to replace wherever we have our answer. So we've got alpha plus beta. Alpha plus beta, we're going to replace it by 2. Then we've got alpha beta, we're going to replace it by 5 over 2. Then we just solve. So in this case, alpha plus beta, we said it is 2. So this will be 2 squared minus 2. Alpha plus beta, alpha beta is 5 over 2. Then we solve. 2 squared, that is a 4, minus, okay, so the 2 and the 2 can divide, so therefore I'm just going to remain with minus 5. And when I say 4 minus 5, that is just a negative 1. So our C, therefore it is just a negative 1. So that's how we solve that one. Okay, let's solve D. So for our D, we are saying it is alpha squared multiplied by beta plus alpha beta squared. So for this one, just try to factorize, you see what you're going to have. Okay, so when we factorize alpha beta, I'm going to have alpha beta outside the brackets. Then here I'm going to remain with 1 alpha, okay, because there were 2. Then plus, then on the other side I'm going to remain with the beta because the beta were squared. Okay, basically this. Then we're just supposed to replace definitely. Then we've got alpha beta. Alpha beta we said is 5 over 2. Okay, 5 over 2. This is multiplying by alpha plus beta. Our alpha plus beta, we've said it is 2. Then we multiply. The 2 and the 2 can divide. Therefore, our final answer is just going to be a 5. So this D gives us a 5. Okay, then we come to E. So how do we solve E? We've got alpha minus beta squared. So for this one, we're just supposed to multiply just the way we multiply squares. So I'm going to say the square is going to drop on alpha and on beta. So what I'm going to do quickly, I'm going to have alpha squared and beta squared. Then what I'm going to put on the middle is I'm going to multiply these 2, multiply by the alpha, multiply by the negative beta. So 2 multiplied by alpha, that is 2 alpha. 2 alpha multiplied by negative b, I'm going to have negative 2 alpha beta. Then I put a plus. Basically, this is what we have. Now that we've got this, I'm going to do something that is very interesting. I'm going to put them in categories, okay? So I'm going to say alpha squared plus beta squared minus 2 alpha beta. Why I've put it like this is because we know what our alpha squared plus beta squared is, Okay, we're just from solving such kind of equation, which is here, the one that we found in -1. Okay, so basically, since we found a -1, I'm just going to put a -1 here. -1 minus 2 alpha beta, we said it is 5/2. We're not just supposed to solve. So I'm going to have -1. Then I've got the 2 and the 2 can divide. Okay, therefore I'm going to have -5. Then -5, -1, that just gives me a -6. Okay, so this expression here gives us a -6. So basically that's how we solve this one. Then for the last set of questions, these are just fractions, how we solve fractions, and we solve. Let's see where we're going to end. So we have got 1 over alpha plus beta, alpha plus 1, 1 over beta plus 1. So for this one, I'm just supposed to find the common denominator. In this case, I'm going to put my alpha and my beta in one bracket. Okay, so I'm going to have alpha plus 1, I'm going to have beta plus 1. Then you know that when you subtract, when you multiply, what we're just going to have on top, I'm going to have beta plus 1, and on the other side I'm going to have plus alpha plus 1, because we only have ones on top. Now that we've got this, we're just supposed to again put them, arrange them in a proper way that you're able to solve. Okay, so in this case, on top I'm going to have alpha plus beta, because we said addition is commutative, plus 1 plus 1. Now 1 plus 1 just gives us a 2, so I'm going to write the 2 in advance, over what we have down as a denominator. I can multiply, so as I'm going to multiply alpha multiplied by beta, that will give me alpha beta. Then alpha multiplied by the 1, I'm going to have plus alpha. Then the 1 multiplied by everything, I'm going to have beta plus 1. Okay, basically this, then I'm just supposed to replace where I need to replace. So where I need to replace alpha plus beta, I can put these ones in brackets, these ones alone as well, and these ones alone like that. Then I replace and I solve. So alpha plus beta on top, we've said alpha plus beta, that is a sum. We found that it was 2 plus 2 on top, over alpha beta, it is 5/2, plus alpha plus beta, we've said it is also a 2, then plus a 1. Then we're just supposed to solve. On top I'm going to have a 4, over down are the 8. I've got 5/2 plus 2 plus 1. I think we solved something like this, but let's still solve it. So I'm going to put 1 here, again I'm going to put 1 here. I'm going to put over 2. 2 into 2, that is a 1. A 1 multiplied by 5 is a 5, plus 1 into 2 is 2. 2 multiplied by 2, that is a 4, plus 1 into 2, that is 2. 2 multiplied by the 2 on top, that is by the 1 on top, that is a 2. 5 plus 4, that is 9. 9 plus 2, that is 11. So I'm going to have 11/2. That is what I have down. So here I'm going to 11/2. So we have a scenario where we have 4 divided by 11/2. So I'm going to rub here. So we have 4 divided by 11/2. When I simplify this, it will be 4 multiplied by 2/11. They are going to swap. The denominator and the numerator swaps. So I'm going to have 2/11. Then I'm just supposed to solve. A 4 multiplied by a 2, that is an 8 over 11. So basically that is what we have for f. So for f we have 8/11. So allow me to just write that. So this is equals to 8/11. So basically that's how we also solve the last 2 questions. These are just fractions. Okay, so let's solve also g. So for g, I'm just going to begin it just the way it is. I'm just going to look for the common denominator here, because it's in a very perfect position. So what will be our so I'm just going to put I'm going to first put them in brackets. So 2 alpha plus beta, I'll put that in brackets. Then alpha plus 2 beta, I'm also going to put that in brackets. Then when we solve, you know, I'm just going to have because there are ones on top, I'm just going to cross multiply. I'm going to have alpha plus 2 beta plus 2 alpha plus beta. Okay, now that we've got this, what are we going to do now? So down I'm going to multiply. On top I'm going to put them the ones with 2 alone. Okay, so I'm going to have 2 beta plus 2 alpha plus alpha plus beta. Okay, are you seeing where we're going? Okay, then when I come down, I'm supposed to multiply 2 alpha multiplied by alpha. I'm going to have 2 alpha squared, then plus 2 alpha multiplied by 2 beta. I'm going to have 4 alpha beta. Then I come to the other side, beta multiplied by alpha, that is alpha beta, plus beta multiplied by 2 beta squared. I'm going to have 2 beta squared, like that. Then I solve. Now what I have on top, allow me to factorize. Since here we have a 2 and here we have a 2, I'll factorize a 2 and I'm going to remain with a 2. Then in the brackets I'm going to remain with beta plus alpha. Beta plus alpha is because this addition is commutative, so I can write it as alpha plus beta. Okay, plus again alpha plus beta. Okay, so we are set on top. We just need to replace. Now we come down here where we have squares. What do we now do? Okay, so is there anything that we can solve? Okay, yes, we can solve something. So we have 2 alpha squared plus 2 beta squared plus, now we've got here, you're able to see that we've got 4 alpha beta and alpha beta. These ones can add, and when we add 4 alpha beta plus alpha beta, what are we going to have? We're going to have 5 alpha beta. Okay, so on top I can replace. I've got 2 alpha plus beta, we said it is a 2, plus alpha beta, we said is 5 over 2. Oh, it's also alpha plus beta, so this one, so that one is also a 2 over. Now allow me now to just factorize a 2. So there's a 2 here, there's alpha squared and beta squared. That is what is going to remain in the brackets when I factorize the 2. Alpha squared plus beta squared, then plus 5 alpha beta. So that is what we have. Allow me to write it on this other side. So I'm going to have when I multiply, when I solve what is on top. Okay, let me first, okay, it's 4 plus 2 over, so down here I'm going to have 2 multiplied by 2 multiplied by, okay, down here I'm going to have 2 alpha squared plus beta squared. We've already found that it was where was that equation? It's here. Alpha squared plus beta squared, we already found that it was a 1 or a negative 1, so I'm going to put a negative 1 here. Okay, then plus 5 alpha beta. Alpha beta, we've said it is 5 over 2. Okay, then we've got this. Then we just we're just supposed to solve. Okay, 4 plus 2, that is a 6 over. Now down we've got 2 multiplied by negative 1, that is negative 2, plus 5 multiplied by 5, that is a 25 over 2. Okay, basically that is what we have. Now for this expression that is down, allow me to solve it from here. I've got negative 2 plus 25 over 5. so plus 25 over 2. So I can put over 1 here, 2 as a common denominator. 1 into 2, that is 2. 2 multiplied by negative 2, that is negative 4. Plus 2 into 2, that is a 1. 1 multiplied by 25 is a 25. Then negative 4 plus 25, it gives us, is it a 21? Yeah, 21 over 2. So that is what we have as 21 over 2. So we are dividing 6 divided by, so we have 6 on top divided by 21 over 2. So this is going to give us 6 multiplied by 2 over 21. Then we solve. 6 multiplied by 2, that is a 12 divided by a 21. Then we look for two numbers, any number that can go into 21 and 12. I think a 3 can do that. So a 3 into 12, that will give us a 4 over a 3 into 21, that is a 7. So basically that is what you are going to have as your answer for G, 4 over 7. So that is what we have. Then let's solve the last question on this on this concept of alpha and beta. So we're able to see that alpha and beta problems are not really a problem. So even this one, let me just solve it just where it is because of its position. So I'm just going to do alpha squared plus 1. Then I'm going to have beta squared plus 1. Then when we multiply them with the ones on top, when we cross multiply, I'm going to have beta squared plus 1 plus I'm going to have alpha squared plus 1. Okay, now that we've got that, allow me to do something interesting on top. I'm going to again replace them, arrange them the way we've been arranging them. So I've got a beta squared and an alpha squared. So these ones I can put them as if they're like terms. So I'm going to say alpha squared plus beta squared. Then I've got a 1 plus a 1. Okay, a 1 plus that 1 will just give us a plus 2. Okay, over. Then down, we're just supposed to multiply them. Okay, so now if I multiply alpha squared plus beta squared, what am I going to have? I'm going to have alpha squared beta squared. Then the alpha squared multiplied by the 1, I'm going to have alpha squared plus. Then the 1 multiplied by everything that is in the bracket, I'm just going to have beta squared plus 1. Now that we've got this, again we're going to do something that is interesting. Now we know what, so I can put this in brackets. Then for this one I can factorize if I want. Then alpha squared plus beta squared, I'm going to also put those ones in bracket. Then we solve. Okay, so let's just do that. Alpha squared plus beta squared, we already solved this one. It gave us a negative 1. Okay, so I'm just going to put a negative 1 there plus a 2. A negative 1 plus a 2, that gives us a 1. Okay, so we have a 1 on top over. Then this one, we're going to do something interesting because the square is the same. So I'm going to put them in brackets. I'm going to say alpha plus beta, then the square outside is still the same. Okay, then plus, then this one alpha squared plus beta squared is the one that we're saying it is negative 1. So that is negative 1 plus a 1. Okay, so able to see that a negative 1 plus a negative 1 just gives us a 0 there, right? Okay, so we have 1 over alpha beta, we said it is 5 over 2. Then this is squared. Then we have the minus 1 plus a 1. Okay, so I'll rub on the other side here. So we have a 1 over 5 squared is 5. 5 squared is 25. Then 2 squared, that is a 4. Okay, minus a 0, that is just a 0 there. Okay, a negative 1 and the 1, that will give us a 0 there. Now that we've got this, we're dividing. So we've got 1 divided by 25 over 4. So every time we're dividing, so this will be 1 times 4 over 25. So now you're able to start. Our answer now is 1 multiplied by 4, that is a 4 over 25. So this last question gives us 4 over 25. So basically this is how you solve questions to do with roots, okay, on quadratic equations. So thank you for watching to the end. See you in other sessions. In this video, we're going to solve quadratic equations with roots. So basically, these are quite different from the ones that we've been solving. Here, you're told to find the equation instead of finding alpha and beta. So basically that. So let's start with the first question, where we're given if the roots of the equation, this equation, are alpha and beta. Then we're told to write down a quadratic equation which has these kind of roots. So basically, how do we solve such type of a quadratic equation? So for the first one, we've been given the roots alpha and beta. Okay, so let's first find what alpha plus beta is and alpha beta is. That is the first thing that you're supposed to do. So alpha plus beta, we know that it is equals to negative b over a. Then alpha beta, that is just equals to c over a. Then we're just supposed to solve this. I'm going to have negative. What is our b in the equation? B is a coefficient of x, which is negative 4 there. So I'm going to put negative 4 here over what is our a. Our a is 1. Okay, so therefore I'm now going to have 4 as alpha beta, as alpha plus beta. Then alpha beta, it is c over a. Our c is 2 over a, which is 1. So this will give us a 2. So allow me to write them on top. Alpha plus beta, we found that it is 4. Then alpha beta, we found that it is a 2. So those are our answers for the sum and the product. Now they've already given you the roots. Okay, they've already given you the answers in simpler terms. So now how do we come up with that equation? So what I'm going to do is that I'm going to find this the sum of the roots and the product of the roots. So let's start with the sum of the roots. So in this case, the sum of the roots, I've got alpha plus 3. Okay, this is adding plus beta plus 3. So what am I going to have if I'm going to find this? I'm going to put because addition is commutative, I'm going to have alpha plus beta, then I'm going to have 3 plus a 3. Then I just solve. Alpha plus beta, we've already found that it is a 4, so I'm going to put a 4 plus a 3 plus a 3 on the other side. That will give me a 6. Then 4 plus a 6, that is a 10. So that is the sum of the roots. We found that it is a 10. So I'm going to write the 10 here. Then let's find the product of the roots. Product of roots. So the product, in this case, we're multiplying the 2. So we've got alpha plus 3. This is multiplying by beta plus 3. Then we're just supposed to solve this. Alpha multiplied by the beta, I'm going to have alpha beta, plus alpha multiplied by 3, I'm going to have 3 alpha, then plus 3 multiplied by beta, that is 3 beta, plus 3 multiplied by 3, that is a 9. Okay, then I'm going to have alpha beta. And then what I'm now going to do is I'm going to say plus the 3 and the 3, I'm going to factorize it. When I factorize it to be 3 over, I'm going to remain with alpha plus beta in the brackets, then plus 9. Then I'm just supposed to solve this equation by replacing. Alpha beta, we've said it is a 4, so I'm going to put a 4 there. Oh, alpha beta is actually a 2 there. So I'm going to put a 2 here plus 3. Then alpha plus beta, it is a 4 plus 9. Then I'm just supposed to solve this. So I'm going to have a to allow me to write it on the other side. I'm going to have a 2 plus a 3 multiplied by a 4, that gives us a 12 plus 9. Then I'm just supposed to solve this. 2 plus 12, that is a 14 plus 9. A 14 plus a 9, what does that gives us? That is 23. Is it 23? Yes, 23. Okay, we have 23 as our product, so our product here, it is 23. Okay, so now that we've found the sum and also found the product using the roots that we've been given, what is the general equation? Okay, we know that the general equation is given by x squared minus the sum of the roots, then x plus the product of the roots. This is equals to 0. So that is how we solve. So basically now what are we going to do? We're just supposed to replace what we have. So this will be x squared minus the sum of the roots. What have we found as a sum? We found that it is 10. So I'm going to put 10. Then we have an x here. I'm going to put x there. Plus, what is the product of the roots? We found that it is 23. I'm going to write it. 23 is equals to 0. So basically this is the quadratic equation that they've asked us to write, having these roots. So that's how we solve this type of question. And all the questions that are preceding and that are following, we're going to solve them just like this. No much difference. So let's solve the second one. For the second one, we've got alpha. Let me first find the sum of the roots. So the sum, in this case, I've got alpha plus 3 beta plus beta plus 3 alpha. Okay, so always come up with an arrangement that is going to simplify things for you. Okay, so in this case, I'm going to put alpha and beta on one side. So I'm going to have alpha plus beta, then the 3 beta plus 3 alpha will be alone, like that. Then I just need to solve this. Alpha plus beta, we've already found that it is 4 plus. Here I'm going to factorize the 3. Then in the brackets I'm going to remain with beta plus alpha. These are commutative, so I can also write them as alpha plus beta. Commutative, we mean they can be interchanged and you're going to get the same answer. So we have 4 plus 3. Now alpha plus beta, it is a 4. So we are going to have 4 plus a 3 multiplied by a 4, that gives us a 12. So we have a 4 plus a 12, which gives us a 16. So alpha plus beta, we found that it is a 16, or the sum of these roots. Now let's find the product of these roots. So the product. So for the product, we're just multiplying them. So we've got alpha plus 3 beta. This is multiplying by beta plus 3 alpha. Then we solve this. So when the alpha multiplies with everything that is in the bracket, what are we going to have? Alpha multiplied by beta, that is alpha beta, plus alpha multiplied by 3 alpha, we're going to have 3 alpha squared, plus 3 beta multiplied by beta, we're going to have 3 beta squared, plus 3 beta multiplied by 3 alpha, we're going to have 9 alpha beta. Okay, basically this. Then what do we do? Just put them in a way that is going to make things easier for you. Okay, so in this case, I'm going to have alpha beta plus, there's a 3 here and there's a 3 there. I'm going to factorize it, 3. Then the bracket, I'm going to remain with alpha squared plus beta squared. Now you remember what alpha squared plus beta squared is. we said this is an equation that you're supposed to know. Okay, so there I'm going to we said if you're given alpha squared plus beta squared, this is the same as alpha plus beta, then this one you square it, then you're going to say minus 2 alpha beta. That's what it equates to. Okay, because it is the same as that. Now if you don't understand about this, how it comes about, you can watch our videos on the roots of a quadratic equation. Just type that, you're going to find them. Such videos are there on YouTube. Now since we have got that, I'm just, instead of me writing alpha squared plus beta, I'm going to write this simplified version. Okay, so I'm going to have alpha plus beta. This is allow me to put it in them in brackets nicely. This is squared minus 2 alpha beta. Then we've got plus, we have a 9, then we've got alpha beta. Okay, now that we've got this, we're just now supposed to replace and solve. So alpha beta, we found that it is a 2 plus, I'm going to have a 3. Then alpha plus beta, we found that it is a 4. So this is 4 squared minus 2 alpha beta, we found that it is a 2 plus a 9 alpha beta, we found that it is a 2. Then we solve these ones. So I'm going to have a 2 plus a 3, 4 squared. Okay, don't forget that these are in the bracket, so you have to solve them the way they are. 4 squared, that is a 16, minus 2 multiplied by 2, that is a 4. So 16 minus 4. 16 minus 4, that gives us a 12. So I'm going to write the 12 in advance here. Then plus 9 multiplied by 2, that is 18. Okay, that is what we have. I can write my answer here. So I'm going to have a 2 plus 3 multiplied by a 12. What am I going to have? So if I multiply 3 by 12, 3 multiplied by 2, that is a 6. 3 multiplied by 1, that is a 30. So I have a 36 plus 18. Okay, then we're just supposed to add these our answers. So if I add 2 plus 36, that is 38. 38 plus 18. Okay, so what is it? 38 plus 18. Let's see. So 18, 38. That is 16, 1. That is a 56. So we have a 56 as our product. So let me write my product here, 56. Okay, so that's how we solve for the product. Then we're supposed to now just put the equation, and everything is done. So basically we said it is x squared minus the sum of the roots, then you have x plus the product of the roots, then it is equals to 0. So therefore, what would be our equation? We're just going to have x squared minus the sum. We found that it is 16, so 16x plus 56 is equals to 0. So that's how we find the equation. So this is the equation that gave us those roots that they've given us. Okay, basically that is the equation that will give us those roots or those answers. Okay, now let's solve another set of questions. So we've got b here, and that is our equation. So from our equation, we're also supposed to find alpha, beta, and like that, all those kind of things. So alpha plus beta, it is negative b over a. Then alpha beta, it is c over a. Then I'm going to have negative. What is our b? Our b is 2 over our a, it is negative 1. So this will just give me a 2. Then alpha beta, the c is negative 7 over our a is negative 1. So this will give me a 7. Is it? Okay, no, our a is a 2, so here it is a 2, even here it is a 2. Okay, so it means my answers have to change. So instead of, because if we say negative 2 divided by negative 2, that is a negative 1. So here having, that is a positive 1 actually. So I have a 1 there. Then on the other side, I'm just going to have a 7 over 2. So our alpha plus beta, it is a 1. Then alpha beta, it is 7 over 2. Okay, that is what we have. Those are our roots. Now that we've got this, we're just now supposed to solve what is the sum and what are the roots. So we only have one question for this one. So the sum of the roots, we've got 2 alpha and 2 beta. So I'm just supposed to add these ones. So we've got 2 alpha plus 2 beta. So when we add these ones, what are we going to have? The common denominator will be alpha beta. Alpha into alpha beta, I'm going to remain with beta. The beta multiplied by the 2 on top, I'm going to have 2 beta. Plus beta into alpha beta, I'm just going to remain with alpha. Alpha multiplied by 2 on top, I'm going to have 2 alpha. On top, I'm going to factorize the 2. I'm going to have alpha plus beta in the bracket over alpha beta. Then we solve. Alpha plus beta, we found that it is a 1 over alpha beta is 7 over 2. So we have this 2 divided by 7 over 2. So we have a 2 multiplied by, it is going to change to 2 over 7. And the 2 multiplied by 2 on top, that is 8 over 7. So the sum, we found that it is 8 over 7. So the sum of the roots, it is 8 over 7. What about the product? So for the product, we're just multiplying the roots. So we've got 2 alpha multiplied by 2 over alpha multiplied by 2 over beta. So what are we going to have? 2 multiplied by 2 on top, that will give me a 4. Alpha multiplied by beta, it's alpha beta. What is alpha beta? So it is 4 divided by alpha beta is 7 over 2. And when we solve, it is 4 multiplied by 2 over 7. And 4 multiplied by 2, that gives us, is it a 16? No, it's an 8 over 7. 8 over 7. Okay, basically, we're able to see that the product is also giving us 8 over 7. Okay. So allow me to erase this part. You have 8 over 7. I'm wondering how we've gotten the same answer. Basically, we have 2 equations. Hope we haven't done. Let's see the first one. How did we solve the first one? So we had 2. We're literally adding them. So that gave us something like alpha beta down. Then we had the 2 alpha, then alpha plus beta in the bracket. Okay, so that was 2. Then alpha plus beta, that was a 1 over 7 over 2. 2 multiplied by 1 on top, that is a 2. So we're dividing this by 7 over 2. That will give us 2 multiplied by 2 over 7. Okay, I've seen why we made the mistake. 2 multiplied by 2 on top, that was supposed to give us a 4 over 7, not an 8 that I've written. Okay, so the sum, it is 8. It is 4 over 7. Okay, basically that. So we're always supposed to counter check in case you've missed one of the equations. So now that we got this, what is the equation now? Our equation will be x squared minus, what is the sum? The sum is 4 over 7x plus what is our product? That is 8 over 7. So basically that's how we solve this one. Let's solve pretty much the last question on this concept. So we're given the roots of the quadratic equation x squared and that are alpha and beta. Write down the terms of p and q, a quadratic equation which has roots, those ones and those ones. Okay, so not very much different from what we've been doing so far. So we've been given alpha, so we're supposed to find alpha and beta. Okay, so alpha plus beta, it is negative b. Now what is our b in this case? You're able to see that the b is a coefficient of x, which is negative p. So I'm going to put negative p here over a. What is our a? Our a is 1. Okay, then we solve. So we're able to see that we're just going to have a p. Okay, so we're going to have a p there. Then alpha multiplied by beta, what are we going to have? That is c over a. What is our c? Our c, we're able to see is a q, so I'm going to write q. Our a is 1. So alpha beta, that is just a q. So I'm going to write them on top. So I'm going to have alpha plus beta, that gives me a p. But alpha beta, it gives me a q. Okay, basically that's what we have. Now let's find the sum and the product. So let's start with the sum of the roots. Okay, we've been given these roots, so let's find the sum of those ones. We're supposed to add them. So I've got alpha squared plus p alpha squared plus beta squared plus p beta squared. Okay, now that I've got this, what do I now do? Arrange it in an order which is easy to solve. So I'm going to have alpha squared plus beta squared, this one. Okay, then what remains, I'm going to put it at the far end. So I'm going to have p alpha squared plus p beta squared. Now that I've got this, alpha squared plus beta squared, we said this is an equation that you're supposed to know, so I'm just going to write it as alpha plus beta, this is squared, minus 2 alpha beta. That's what it means. Okay, plus then p, I can factorize the p, then I'm going to remain with alpha squared plus beta squared in the brackets. Then alpha squared plus beta squared in the brackets, we said again it's the same as this expression that we've written. So I'm going to write it in advance again. So I'm going to have alpha plus beta squared, okay, beta squared minus 2 alpha beta. Okay, like that. Then we're supposed to now solve this. So I'm just going to be replacing and solving. Alpha plus beta, we found that it is p, so this will be p squared minus 2. Then alpha beta, we found that it is q, so I'm going to write q there, plus p. Then alpha plus beta in the brackets, that will give us p again, so this will be p squared then minus 2 alpha beta, we found that it is q, so I'm going to have 2q. Okay, then we solve. So I'm going to have p squared minus 2q plus, then I distribute in the bracket, p multiplied by p squared, that will be p cubed, minus p multiplied by 2q, I'm going to have 2pq. Okay, then is there anything that we can add and subtract here? There is nothing. So basically that is our sum. So in this case our sum for this equation, let me just write it nicely here, before I rub it prematurely. So this is p squared minus 2q plus p cubed minus 2pq. I know I'm supposed to write it, in descending order. We're going to write that when we're writing our equation. Okay. Then what about the product of the roots? So the product of the roots, we're just supposed to multiply those ones. So we've got alpha squared plus p alpha squared. This is multiplying by beta squared plus p beta squared, like that. So for this one, we're just multiplying. Okay, now when you multiply alpha multiplied by beta, that will give us alpha beta. This will be squared, right? However, we know that these ones, when you factorize it, it's just the same as you having alpha and beta squared. Okay, plus then the same alpha squared multiplied by p beta squared. So I'm going to have p again, I'm going to have alpha squared plus beta multiplied by beta squared, and this is just the same as like the previous one. It's going to be alpha plus beta, or alpha multiplied by beta squared. Okay, we come to the other side. We're multiplying by p alpha beta multiplied by beta squared. So it's also going to be the same. I'm going to have p, I'm going to have alpha beta, this will be squared, plus p alpha squared multiplied by p beta squared. I'm going to have p squared alpha squared beta squared. Okay, so because I've got alpha squared and beta squared, I'm also going to do the same, okay, to the way we did the previous ones, So I'm going to write my p squared down, then I'm going to have alpha beta, then the square outside. Okay, basically this. Then we're just supposed to replace where we need to replace. Alpha beta squared, alpha beta is a p, it's a q actually, so it will be q squared plus p. Then alpha beta, it is still a q, so I'm going to write q, this will be squared, plus p. Alpha beta again is a q, so I'm going to have q squared there, plus p squared. Alpha beta is still a q, so I'm going to have a q squared there. That is our product, unless if there's something that we can add and subtract. So let's see what we now have. Allow me to erase this part so that we write our equation there. Okay, I don't want to rub it prematurely so that we don't miss some important details from my equation. Okay, so basically that, so this the product of these roots, we've got q squared plus p q squared plus p q squared. So able to see that we've got these ones, pq squared plus pq squared. Since there are the two of them, I'm going to add them. When I add them, that will just give me 2pq squared. Okay, then plus the last part, it is p squared q squared. Okay, basically that is what we have as our product. So now what will be our final equation? So the equation now will be x squared minus, what is the sum of the roots? Put it. So that is p squared minus 2q. Okay, let me I promise that I'm going to put them in starting from I'm going to put them in descending order. So I have a p cubed plus p squared minus, okay, we've got a 2q and a 2pq. These ones are different. Okay, so because they're different, I'm just going to write them the way they are. So I'm going to minus 2q minus 2pq. Okay, that is our sum. I'm going to put x here plus the product. You write the whole expression for the product, which is x q squared plus 2p q squared plus p squared q squared. So basically this is how you solve, you know, the equation, how you find the equation when you've been given the roots of a quadratic expression. Not simple, just you know, just applying the principles of alpha and beta. Thank you, and see you in other sessions. In this session we're going to find the nature of the roots. Now we're going to find the nature of the roots using the discriminant. However, here we're not solving, but the discriminant, like we earlier said in other sessions, it gives us the nature of the equation, or how the equation is going to behave. Okay, so basically let's start with the first question. So we've been given to find the nature of the roots, and this is our equation. So we're supposed to find the discriminant. The discriminant is going to tell us what roots we're going to have, okay, whether they're going to be equal, whether they're going to be complex, all those kind of things. So let's start. We know that the discriminant is that expression that is found in the quadratic expression, okay, in the root, this one, b squared minus 4ac. That is the discriminant, the one that is found inside. It tells us the nature of the roots. So in this case it is b squared minus 4ac. So then I'm just supposed to replace our a. In this case it is a 4, our b it is a 20, our c it is 25. Then I just solve. So b squared that will be 20 squared minus 4, our a it is a 4, our c it is a 25. Then I just solve. 20 squared, that is it a 400, minus, then I'm going to have 4 there, 4 multiplied by 25, I'm going to have is it 100? Yeah, 100. So I'm going to have a 400 minus 400. 400 minus 400, that just gives us a 0. So I'm able to see that the discriminant itself, it gives us a 0. And every time the discriminant is equals to 0, we have equal roots. So in this case we have equal roots. That's the nature of the roots that we have. They are equal. Okay, basically that. So let's come to the second question. So for the second question I'm going to do the same. My a is 1, my b is 4, my c is 7. Then what do we now do? The discriminant b squared minus 4ac is equals to 0. B squared, that is 4 squared minus 4, our a is 1, our c is 7. Then we solve. 4 squared, that is a 16, minus 4 multiplied by 1 is a 4. 4 multiplied by 7, 4 multiplied by 7, what does it give us? That is 20 what? 28. Okay. Then a 16 minus a 28, that gives us a negative, let's see, 8 minus 6, that is a 2. 2 minus 1, that is okay. So it gives us a negative 12. So now we're able to see that the discriminant is equals to negative 12, and negative 12 is less than 0. Okay, because negative 12 is less than 0, what this means that in that root you have a negative 12. Okay, so now because you have a negative 12, you know that every time you have a negative in the root, that is imaginary. Those are complex roots. So in this case, the nature of these roots, the ones that we are going to have even before we even solve the equation, we're able to tell that we're going to have complex numbers. So the answer in this case, we're going to have complex roots. Okay, then it depends, others might call them, depending on the literature that you're using, they can also call them imaginary roots. So basically that's how you solve this one. Let's solve question number 3. So we've got we're supposed to find A, B and C as well. So just to make our work easy, our A is 16, our B is 40, our C is -25. Now that we've got that, we're going to now find the discriminant, which is B squared minus 4AC. Our B squared, so we're going to have 40 squared, okay, minus 4. Our A is 16, our C it is -25. Okay, we literally have big numbers here. Okay, so I'm going to use the calculator to solve this one. So 40 squared minus 416 multiplied by minus 25. Okay, it gives me 3,200. So now I'm able to say that the discriminant is equals to 3,200. This is greater than 0. Okay, so because this is a bigger number, if in the root you have any number that is bigger than 0, let's say this same 3,200, it means you are going to have two answers. Okay, you are going to have two answers. Those two answers, they are not we call them two distinct roots. So in this case, the nature of the roots that we are going to have, it is we have two distinct, since these are real numbers, I'm going to say real roots. So that is how we solve this one. So basically that's how you solve to find out the nature of the roots. Okay, in this session we're going to solve this question. So without wasting much of the time, let's start. So we're told to find the values of k, or the range of values of k in each case below. So starting with the first one, the roots of this equation, they differ by 2. Okay, so you know that the roots are alpha and beta, right? So it means we're supposed to first find what alpha plus beta is, which we know that it is negative b over a. Then we're also supposed to find what alpha beta is, which is c over a. Now if I solve alpha plus beta, so if I look at this equation, so I've got negative, then b is a coefficient of x. In this case, the coefficient of x, it's a 5. Okay, so since it's a 5, I'm going to write it's -5 actually attached to x over a. Our a is 3, so therefore this will be 5 over 3. That is alpha plus beta. Then alpha beta, when we divide the two, c, that is k, over a, that is a 3. Okay, so basically this is what we have. So for this one, alpha plus beta is equals to 5 over 3. Then alpha beta is equals to k over 3. Okay, so I'll keep that because we'll need it later on. Now for us to satisfy this condition, they've told us that when we solve this root, the roots of this equation is going to give us 0. However, the roots themselves, they differ by 2. Now if I'm going to pick the roots, if I'm going to pick two roots, let's say there's alpha. If one is alpha, what will be the other root? Okay, since these roots differ by 2, the other root is going to be alpha plus 2. To differentiate that, the difference between these two roots is 2. Now that I've got this, I can now solve for our equation. We found that alpha plus beta is equals to 5 over 3. Okay, so what this means is that if I'm going to get these equations that I've written, when I add them, alpha plus 2 should give me the sum in this case, which is 5 over 3. So I'm going to have 5 over 3 here. Now I'm just now supposed to solve this. Now alpha plus alpha, that will give me 2 alpha plus 2 is equals to 5 over 3. Now for me to remain with my alpha, I'm going to say 2 alpha will be equals to 5 over 3. Then I'm going to take the positive 2 to the other side and it will become a negative. So I'll have a negative 2 this side. Therefore now what I have is 2 alpha is equals to 5 over 3 minus 2. I can find the common denominator. In this case it is 3. 3 into 3, that is a 1. A 1 multiplied by a 5 on top, I'll have a 5 minus 1 into 3, that is a 3. A 3 multiplied by the 2, it is a 6. Okay, so I have a 2 alpha that side. So 2 alpha now will be equals to 5 minus 6, that is a negative 1. Okay, negative 1 over 3. Now for me to remain with my alpha on this case, I can multiply by 1 over 2 on both sides. 1 over 2 on both sides. Why I'm multiplying by 1 over 2 is because I want the 2 and the 2 to cancel, so that I just remain with my alpha. So in this case, our alpha will be equals to the negative 1 multiplied by the 1, that will give us a negative 1. Then the 3 multiplied by 2, that will give us a 6. So that is our alpha. We've found what our alpha is. Now let's find the product. Okay, since these are our roots, now we're not just adding them, we're now multiplying them. So I'm multiplying alpha multiplied by alpha plus 2. This is going to give us a product. Now have we already found the product? Yes, our product is k over 3. So I'm going to write k over 3. Now that we've got this, we just need to solve. Now if I multiply alpha multiplied by alpha, what am I going to have? I'm going to have alpha squared plus 2 alpha. Okay, this will be equals to k over 3. Then I'm supposed to cross multiply here. When I cross multiply, k will be equals to 3 multiplied by alpha squared, that will be 3 alpha squared, plus 3 multiplied by 2 alpha, that will be 6 alpha. Okay, now that I've got this, what do I know from here? K over 3. Okay, I'm trying to come up with how we can manipulate this one. Okay, alpha, we've already found alpha though. So now, okay. So for this one, I'm going to replace alpha because I've already found my alpha, which is negative 1 over 6. So I'm going to now just replace. I was trying to come up with numbers that can just simplify it. Anyway, we've got alpha squared, that is negative 1 over 6. This is squared plus 6 multiplied by alpha, which is 1 over 6. 1 over negative 6. Okay, basically that. So therefore now what will be our product? K will be equals to the 3 divided into 6, that is a 2. So I'm going to have negative 1 over 2. Okay, but before I do that, there's a square outside. There's this square. So it means first, before I do that, let me put my 3. 1 squared, that will be a 1. Okay, then 6 squared, that will be 36. Okay, there was a negative, but because we are squaring, the negative is going to go. Okay, plus 6 divided by 6, that will just give us a 1. So this side we're just going to have a negative 1. Okay, now when we are here, we're just now supposed to solve. So I've got 3 into 3, that is 1. 3 into 3, that is 1. 3 into 6, that is 12. So we're going to have 1 over 12 minus 1. okay, 1 over 12 minus 1. Okay, so that is our equation. Now let's solve for k. Therefore our k now will be k will be equals to, we've got 1 over 12 minus 1. So the common denominator in this case, it is 12. 12 into 12 is 1. 1 multiplied by 1 is 1. Then 1 into 12 is 12. 12 multiplied by the 1 on top, that is 12. So therefore our k will be now finally, because 1 minus 12, that is 11. So negative 11 over 12. That is our k in this case. So basically we found what our k is now. Okay, so that's how we find the value, okay, of k. So if you want, for you to find the alpha beta, just replace k with the negative 11 over 12. However, I just wanted to show that the roots differ by 2. So basically that is our answer. Now let's come to the second one. For the second one, we're told that the roots of 3x squared plus k minus 1x minus 2 is equals to 0. Then we're being told that these roots are equal and opposite. So always go to the condition. They are equal and they're opposite. So if they're equal and they're opposite, let's say if I've got alpha and alpha, are these ones equal? Of course, but for them to be opposite at the same time, I'm supposed to make one to be negative, okay, to show that this one is positive, the other one is negative. They are opposites of each other. So basically these are the roots that we're talking about. However, we're supposed to find the sum and the product based on the equation that they've given us. Okay, so in this case, what are we going to do? You know that alpha plus beta. Okay, but in this case, since we've chosen the roots to be alpha and negative alpha, so I'm going to say alpha plus negative alpha. Okay, it should give us negative beta, or in this case, negative the coefficient of x, which is k minus 1. So that is negative k minus 1 over a. Our a in this case is a 3. So I'm going to put over 3. Okay. Then here I solve. Okay, now when I solve, I'm going to have alpha. This is minus, this is plus and minus. So I'm going to have minus alpha, which will just give alpha minus alpha will give us a 0. So I'm going to have 0 is equals to, now when I distribute this negative into this bracket, I'm going to have negative k plus 1 over 3. Now when I cross multiply, what am I going to have? A 3 multiplied by the 0, that will just give us a 0. So we're going to have 0 is equals to negative k plus 1. When I take the negative k to the other side, I'm going to have k is equals to 1. So we found the value of k to be equals to 1. And basically that is the answer, because we are looking for the value of k, okay, based on the information that we've been given. Therefore our k is equals to 1. So let's stop the third one. For the third one, we are told the roots of x squared 2 minus kx is equals to 2k and is equals to 0 are real and distinct. So they've put these ones are real and distinct. So what are we talking about? We're talking about the discriminant. For them to be real and distinct, we mean that the discriminant is greater than 0. Just to remind you, the discriminant is that thing or the number that is found in the root in your quadratic expression. Usually we say x is equals to negative is it b x is equals to what's that, negative, let's say negative b positive or minus the square root of b squared minus 4ac over 2a. Okay, that is the quadratic equation. However, the discriminant is this part that you have in the bracket. Okay, that one is going to determine the nature of the roots that you are going to have. So now we've been told that these roots are real and distinct. Okay, real to mean they're just real numbers. Distinct, they are different numbers. They are two different numbers. Let's say, for example, you have a 2 and a 3 as your final answer. Another example that I can give is you have a 2 and a 5. As long as they are different, those are distinct. Okay, now we've been given this equation. Okay, so now what are we now going to do? The discriminant is given by b squared minus 4ac. So what is our a in this case? Our a is 1. What is our b? Our b is 2 minus k. What is c? Our c is negative 2k. Negative 2k, that is our c. Now when we replace, what are we going to have? B squared, that is 2 minus k, this will be squared, minus 4. Our a is 1, our c is negative 2k. So basically this is what we have, and we're just supposed to solve this. So what are we going to solve? If I square 2, I'm going to have 4 squared, I'm going to have a 4, and then a 2 multiplied by a 2, that is a 4. A 4 multiplied by negative k, I'm going to have negative 4k. Then the negative k squared, that will give me positive k squared. Okay, minus the 4 multiplied by 1, that is negative 4. Negative 4 multiplied by 2k, that will give us a positive 8. Okay, so I have a positive 80k. Now this is what I have. Can we simplify it further? Of course. Let me first start with the one that is squared. So I'm going to have k squared, then plus what can we do? Okay, we've got 8k, we've got 8k, and we've got 4k. Okay, so 8k minus 4k, that is plus 4k. Okay, then we've remained with a 4 plus 4. Okay, basically that. Therefore this should be greater than 0. Okay, because we're saying these are real and they are distinct. Okay, now we found that that is the equation that we have. We're supposed to solve that equation. Okay, we're supposed to solve this equation if we can. So what are we going to like have? Now for us to have this, what can we do? Okay, so basically we are the scenario where you have k plus 2 squared. It's the only expression that can give us this expression. Why, if I say k, that would be k squared, then 2 multiplied by k, that is 2k. 2k multiplied by 2 the other side, I'm going to have plus 4k. Then when I square root the 2 on the other side, I'm going to have a plus 4. So that is the expression that will give us that expression. So I've just written it like that. Now if that is the case, this should be greater than 0. Okay, it's the same as this expression. Why I'm writing like that? Because I want to come up with what we call critical values. So my critical values in this case, if I'm going to say k plus 2, this is squared, is equals to 0. If I square root on both sides, I'm going to have k plus 2 is equals to, the square and the root are going to cancel. The square root of 0 is a 0. Therefore my k will be equals to negative. When the 2 goes on the other side, it will be equals to negative 2. So if my k is equals to negative 2, I'm supposed to draw a diagram. Okay, so let's say this is our simple diagram. Okay, like that. Then since k is equals to negative 2, let me put negative 2. Then the equation that we had, that was k plus 2. Okay, and I square like that. Okay, what this means is that we're going to get any number that is less than negative 2 and replace in the equation to see what we are going to have. So if I say, let's say I pick a negative 4. Now whatever I'm going to put in this bracket, whether it's negative or positive, I'm always going to get a positive answer because it is squared. Okay, so here I'm going to have a positive. Then let's get a number that is greater than 2. Let's say we put a 0 here. Okay, a 0 plus 2 squared, that will also give us a positive answer. So this is also positive. So basically, because all of them are positive and we want numbers that are greater than 0, okay, we want all the numbers that are greater than 0, because we said in this they are real and distinct. So basically, what are those numbers that are greater than 0? So basically, our solution set, we're going this side and we're also going the other side. Okay, we want positive values. So in this case, our answers will be k. In this case, it should be less than -2, meaning we're going in this direction. Then or k should be greater than -2, meaning we're going that side. Those are the solutions for k. Okay, so that's how we solve this question. You are literally using your critical values. So let's solve another one. So for IV, we've got 2x squared plus kx minus 15 is equals to 0 has only root 3. So this one they've already told you you only have one answer, which is a 3. Since we only have the one answer, which is 3, x, meaning x is equals to 3. So because x is equals to 3, get your equation 2. Wherever there is x, put the 3. So in this case, it will be 3 squared plus k 3 minus 15. This should be equals to 0. Then solve and find the value of k. So in this case, 3 squared, that is a 9. Then plus k multiplied by 3, that is a 3k minus 15 is equals to a 0. Now that we've got this, a 2 multiplied by 9, that is 18, plus 3k minus 15 is equals to 0. 18 minus 15, I'm going to have a 3. So I'm going to have a 3 plus 3k is equals to 0. When I take the 3 to the other side, I'm going to have 3k is equals to -3. Then I divide by 3 on both sides. Okay, therefore what would be the value of k in this case? -3 divided by 3, that is a -1. So basically, that is the answer for k. So the values for k, not only do we have 3, we also have -1. So k is also equals to 3. Okay, so basically that is how you solve this one. So let's solve question number 5. So for question number 5, we're saying after you solve this question, the roots has roots whose sum is equal to 6. Okay, so when you add your roots, you're going to get 6. Okay, so if the roots have got a sum of 6, so let's say the sum, we know that is alpha plus beta, right? So when you add them, they are going to give you 6. That's what it means. Okay, now how do you find alpha beta? We say alpha plus beta, we get it's -b over a. From our equation, what is our so I'm going to put negative, then beta, in this case our beta is k, right, the coefficient of x, so I'm going to put k there, over what is our a there is 3, so I'm going to say 3. So able to see that alpha plus beta should be -k over 3. So because that is what we are supposed to have, therefore I'm just supposed to solve it just the way it is. So what this means is that alpha plus beta, since it's equals to 6, so 6 is equals to -k over 3. That's the only way we can find k. So what will be k? In this case, when I cross multiply, -k will be equals to 6 multiplied by 3. -k will be equals to 6 multiplied by 3, that is 18. So therefore, for me to remain with my k, I'm supposed to divide by a negative. So therefore, k now will be equals to -18. So that is the value of k. Okay, let's solve vi, the last question. So for the last question, 5x squared minus 8x plus k is equals to 0 has roots whose product is equal to 1 over 5. Whose product? The previous one we're finding the sum. Now here we're finding the product. How do we find the product? Alpha beta is equals to c over a. What is our c in this case? C is k, a is 5. So therefore this is equals to k over 5. We've found our product, but now we've been told that the product is equal to 1 over 5. So therefore this will be equals to k over 5 is equals to 1 over 5. Then when you're here, we're just supposed to solve. Now if I cross multiply, I'm going to have 5k will be equals to 5. For me to remain with my k, I'm going to divide by 5 on both sides. My k will be equals to 5 divided by 5, that is equals to 1. So basically that is the value of k. So this is how we solve, you know, questions when you're given the roots, then you're taught to find the range of values. It can either be of x or k or any letter. So basically that. In this video we're going to solve modulus equations. So without wasting much of the time, let's start. The first question is telling us to solve each of the following equations. So we've got absolute bars 2x minus 5 is equals to 9. Now the way we solve modulus equations, there are different methods, okay? So you can get what is in the bracket and you say 2x minus 5. This can be equals to positive or minus 9. Then you solve each of the individual equations. So let's start with positive 9, or you can also write 2x minus 5 is equals to negative 9. Then we solve these equations. So I'm going to have 2x is equals to 9. When I take the 5 to the other side, because it's negative, it's going to become a positive 5. Okay, so I'm going to have 2x is equals to 9 plus 5, that will give us a 14. Then if I divide by 2 on both sides, my x is equals to 14 divided by 2, that will give us a 7. Now I come to the other side for the other equation. I'm going to have 2x is equals to negative 9. When I take the negative 5 to the other side, it becomes positive 5. Therefore I'm going to now have 2x will be equals to negative 9 plus 5, that will give me a negative 4. Then I divide by 2 on both sides. My x will be equals to negative 4 divided by a 2, that will give me a negative 2. So basically these are the solutions. Now for modulus functions, you have to test your values if they are going to apply there. Okay, so now let's just try. We found negative 2 and negative 7. We've found negative 2 and 7. You have to always test your values. So we're going to have 2. Let's start with 7 minus 5. Is this equals to 9? Okay, 2 multiplied by 7, that is a 14, minus 5, absolute bar is equals to 9. 14 minus 5, that gives us a 9, is equals to 9. The absolute value of 9, that is 9. So able to see that 7 is a solution. What about negative 2? Okay, so we say 2 minus 5 is equals to 9. So 2 multiplied by 2, that is a 4, minus 5. That is going to give us a 9. Then we solve 4 minus 5. That gives us okay, that gives us what? It gives us a negative 1. Then the absolute value of a 1, that is a 1. So able to see 1 is not equals to 9. So basically negative 2 is not a solution. Okay, negative 2 is not a solution. So basically this is how you solve modulus equation S, and that's how you're going to be solving all of them. Okay, let's solve also the second one, B. So for B we have 10x minus 3, this is equals to 0. Now 0 can either be positive or negative, but at the end of the day 0 is neutral. So because it's neutral, we're just going to solve only one equation here. So we're going to have 10x minus 3 will be equals to 0. Then we solve for x. So I'm going to have 10x is equals to, when the negative 3 goes to the other side, it becomes a positive. So I'm going to have 3 on the other side. Then I divide by 10 on both sides. Therefore now our x is going to be 3 over 10. So basically that's how we solve this one. Let's go to C. We've got 5x plus 9 in absolute bars. This is equals to negative 3. Okay, so this is an interesting one. What you should understand is that for this one there is no solution. So why there is no solution? The reason is very simple. Every time you've got something in the modulus, however big it is, whichever sign it has, whether it's negative or positive, you are never going to have a negative answer no matter what. So basically here you don't even have to solve, because there is never number that you're ever going to put in this modulus function that is going to give you a negative answer. All of them, they're supposed to give you a positive answer. So basically there is no solution for this one. Let's solve a different set of questions. So we've got absolute bar of x minus 2 is equals to 3x plus 1. So how do we solve this one? So even this one, there are different ways. You can either the way we did for the previous one, or you're just going to square both sides. Okay, so how are we going to solve this one? So I'm going to say x minus 2, I square this, I've removed the modulus, is equals to 3x plus 1, then I square like that. Okay, then for this I'm just supposed to now solve what I have. Now let me start with this other side. If I say 2, I'm going to get my first x, I square it, then when I square negative 2, I'm going to have positive 4. I'm going to write positive 4 here, then I'm going to put plus, then I'm going to now multiply 2 multiplied by x, that is 2x. 2x multiplied by negative 2, I'm going to have negative 4x. Then here I put a plus. So that's how I solve this one in a simple way. So for the second one, I'm going to do the same. If I square 3x, what am I going to have? I'm going to have 3 squared, that is a 9, x, it will be squared like that. Then if I square the 1 on the other side, I'm just going to have 1 squared. Then what is on the middle? I'm going to multiply 2 multiplied by 3x, that is a 6x. That 6x multiplied by a 1, it used to be a 6x. So I'm going to have plus 6x plus a 1. Then from here, you put the like terms together. Okay, so I've got x squared. Okay, let me take the x squared to the other side to avoid a lot of negatives. So I'm going to take the x squared to the other side. Then I'm going to bring the 6x to the other side. Okay, let me take almost everything on the same side actually. So I'm going to have okay, I'm going to have x squared minus 9x squared plus 4x minus 6x plus 4 minus 1 is equals to 0. Okay, so x squared minus 9x, that will give us negative 8x squared, plus, is it a plus? So we've got 4x minus 6x, that will give us a negative 2x. Then 4x minus 1, that will give us a positive 3 is equals to 0. So able to see that this becomes a quadratic. Now you're supposed to solve this quadratic, and basically we know how we solve quadratic equations. Okay, so I'm not really going to solve the quadratic. Okay, but if we were to solve the quadratic, the solutions, just try to confirm. You're going to have x is equals to 1 over 4 and x is equals to negative 3 over 2. Basically those will be the solutions. Okay, let's also solve for e. So able to see most of these ones are going to be giving us quadratics. So what just tells you is that you can also watch our videos on how we solve quadratic equations. Okay, so we have 4x plus 3 in absolute bars is equals to 3 minus x. So we're also going to do the same like we did for the other one. So I'm going to have 4x plus 3. This will be in absolute bar. Oh, look at, to be in brackets like that. I square it. I get also on the other side, I also put it in brackets, then I solve. Now if I square 4x, what am I going to have? 4 squared, that is a 16. I'm going to have x squared. Then 2 multiplied by 4x, that is 8x. 8x multiplied by 2, that is plus 24x. Then plus 3 squared, that is a 9, is equals to, I come to the other side, 3 squared, that will give us a 9. Then 2 multiplied by 3, that is a 6. A 6 multiplied by negative x, I'm going to have negative 6x. Okay, then negative x squared, that will give me a positive x squared. Okay, basically this, then you're supposed to now put the like terms together and solve the quadratic. So we're going to have 16x squared. When I take the x squared to the other side, I'm going to take everything on this side to the other side. Okay, so this side is x squared. When it goes on the other side, it becomes negative x squared. Then I've got a plus 24x. Then the negative 6x, when I take it to the other side, is going to be positive 6x plus 9. The 9, when I take it to the other side, it becomes negative. I'm going to have negative 9. This will be equals to 0. Then I'm going to have 16x squared. Okay, I'm supposed to subtract here. 16x squared minus x squared, that will give me 15x squared, plus 24x plus 6x, that will give me 30x. Then 9 minus 9, that is a 0. Okay, I'm going to have is equals to 0. Now that I've got this, allow me to factorize the 15. Let's solve this quadratic. At least this one we don't have a lot, so I'm going to factorize the 15. Let me factorize the 15x actually, because it's common on both sides. So I'm going to have 15x. Here I'm going to remain with x plus 2. This will be equals to 0. So now from my equation, what this means is that it means that 15x is equals to 0, or the x plus 2 is equals to 0. Then I'm just supposed to solve these two equations. So I'm going to divide by 15. X will be equals to 0 divided by 15, that is a 0. So that's one of the solutions for x. Then for the other one, I'm going to have x is equals to, when I take the 2 to the other side, it becomes a negative 2. Okay, so these are the solutions for this question. Okay, let's solve the last question. So we have the absolute value of 2x minus 1 is equals to the absolute value of 4x plus 9. Okay, so this is an interesting one. So because we've got absolute values, you can do like we did for the previous ones, you just square the other side. But of course, let's not forget the previous simple one where you just get 2x minus 1 is equals to the 4x plus 9, or 2x minus 1 is equals to, you put a negative 4x plus 9. Okay, then you solve. So 2x when I take the 4 to the other side, the 4x to the other side, I'm going to have negative 4x is equals to 9. When I take the 1 to the other side, it's going to become plus 1. Then 2x minus 4x, that is a negative 2x, is equals to 9 plus 1, that is a 10. When I divide by negative 2 on both sides, my x is equals to 10 divided by negative 2, that is a negative 5. Okay, so that's one of the solutions. When I come to the other side, 2x minus 1 is equals to, I'm now supposed to distribute this negative in the brackets. I'm going to have negative 4x, negative 9. Then from here I put the like terms together. I'm going to have 2x. When I take the negative 4x to the other side, it's going to be positive 4x. This is equals to, I'm going to have negative 9. Then when I take the negative 1 to the other side, it becomes a positive 1. Then I solve. 2x plus 4x, that is a 6x, is equals to negative 9 plus a 1. That gives me a negative 8. Then I divide by 6 on both sides. Therefore my x now will be equals to, I'm just supposed to look for one number that can divide into negative 8 and 6. I'll pick a 2. A 2 into negative 8, that is a negative 4. Then a 2 into a 6, that will be a 3. So basically these are the solutions for this equation. Basically this is how you solve modulus equations. Don't forget to subscribe to our channel as we share more content. In this video we're going to solve some questions on piecewise functions. Basically how to graph piecewise functions using these questions that are displayed here. But now someone might ask, what is a piecewise function? A function that has got sub-functions. They can be 2 or more. That is called a piecewise function. So for example, this one g of x, it has got about 3 sub-functions in it. So basically that is what we call a piecewise function. Now let's start with the first one. We've got f of x is equals to, so we've got 4. Then we've been given the domain. That's the goodness with piecewise functions. You are already given the domain, so it's very easy for you to graph your functions. So let's start with the first one. I'm going to come up with a table of values. So I've got x is greater than or equal to 0. So if I'm going to come up with a table of values, this is x and y. Now x is greater than or equal to 0. So I want all the numbers starting from 0 going up. So we're going to go to 1, we're going to go to 2. So basically I'm just going to get 3 numbers for our graph. So it will be 0, 4, 1, 4, 2, 4. Why I'm concluding like that is because this has already given us a value of 4. So it means on that line every y value is just going to be a 4. Okay, same with the second one. So I've got x and y. For x, we want values of x that are less than 0. Okay, and 0 is not included. So it means I'm getting numbers -1, -2, -3, and I'm going like that. However, I'm just going to end at -3. Now all these are going to give us one value of -4. So I have -4 there, -4, -4. basically this is the information that I have for now, and it is very much enough for drawing our graph. So let's say this is our graph, that is our y-axis, and this is our x-axis. Now how do we now show this? So I've got, let me start with the first one in red. So x 0, 0, so I can put my numbers, okay, let me start with negative 3 this side, negative 2, negative 1 this side. I'm going to have 1, 2, 3, even 4. Then for y, I'm also going to put, let me end at the least is negative 4, the highest is 4. So I'm going to have 1, 2, 3, and 4. Then down I'm going to have negative 1, negative 2, negative 3, and negative 4. So basically this is what I have. Now I'm just supposed to now put the points. So the first point is 0, 0, 4. 0, 4, it is going to be here. Then the second point is 1, 4. 1, 4. So 1, 4 for x, it will be here. Then 2, 4, it is going to be there. So able to see that all our values, if we're going to put 3 here, it is also still going to be 4. That. So you're able to predict that it is going in that direction like that. Then let's come to the next one. We've got negative 1, negative 4. So negative 1, negative 4, it be somewhere there. Negative 2, negative 4, it will be somewhere there. Negative 3, negative 4, it will be somewhere there. And you're able to see that this one is also going in that direction. So then you just have to join these lines. Okay, you join these lines like that. So these lines are not joining anywhere, so it's even easy to tell if this is a discontinuous or a continuous function. So basically that. Now let's come to the second one. For the second one, we are finding g of x. So those are our values. So let's start with x and y. So if this is going to be our table of values, that is y. Now we're getting x is greater than or equal to 2. Okay, so what numbers that are greater than or equal to 2? So I'm going to start at 2 itself, then 3 and 4. I'm just going to pick 3 numbers. Then all these ones are going to be giving us 4. Okay, 4. Why? Because here it's showing 4. Then let me come up with another table of values for the second equation. I'm going to have x and I'm going to have y there. So now we want x is in between negative 1 and 2. Now which numbers are between negative 1 and 2? Or what this means is that x is greater than negative 1 but x is less than 2. So which numbers are greater than negative 1? Or numbers that are between negative 1 and negative 2. So we have a 0 after negative 1. Then we have a 1. Okay, I think basically those ones. Those are the two numbers that are in between. Now if I put 0 in the equation where we have negative x, what answer am I going to get? I'm going to have negative 0, and since 0 is neutral, I'm just going to write 0. Then if let's say I put a 1 here, what am I going to have? I'm going to have a negative 1. So negative 1 there. So that is for our next equation. Then for the last equation, we have x plus 2. So I'm going to again come up with a table of values. Okay, so for the third one, we've got x plus 2. Okay, now what are the values of x that we want? our domain, we've been given that x is less than or equal to -1. So less than or equal to -1, because it is equal to, we're also going to include -1 there. So less than or equal to -1. So we're going to start at -1. The number that is less than -1, -2, -3. I'm just going to pick the first 3. Then what are they giving us? They're giving us x plus 2. So in this equation, if I replace the -1 that I've put there, what do I have? I'm going to have -1 plus 2, which will give me a 1. Okay, so I'm going to put a 1 here. Then in the same equation, now we are going to put -2. Okay, so it will be -2 plus 2, which will just give us a 0. So this is a 0. Then if I put a -3 plus 2, what am I going to have? I'm going to have -3 plus 2, that is a -1. Okay, so I'm going to have a -1 here. So basically these are the 3 equations that we have, and these are the points that we have. So we have everything that we need to graph these 3 functions. So let me say this is our y-axis, this is our x-axis. Okay, so I think from the numbers, from the points that we've picked, the highest that I can just see is a 4. Okay, so this side I'm going to put 1, 2, 3, 4. This side I'm also going to put 1, 2, 3, and 4. These are negatives. Then this other side I'm going to put 1, 2, 3, 4 as well. These ones are also negatives. Then this side I'm going to put 1, 2, 3, and 4. Okay, those are positives. Now let's start with the first answers that we got. So the first point is 2,4. 2,4, it will be somewhere here. Then 3,4, it will again be somewhere there. 4,4, somewhere there. It's just that straight line. It's a straight line. Okay, then we come to the second one. The second one is 0, 0, then 1, -1. So 0, 0, we know that it's just this middlemost point. I'm going to shade using green. The middlemost point is 0, 0. Then the next point is 1, -1. Okay, 1, -1. 1, -1, it will be somewhere here. Okay, then the last one, it is this one. For the last one, we have -1, -1. -1, is somewhere here. Let me use a different color. It's somewhere here. Okay, then we've got -2, 0. -2, 0 is somewhere there. Then we've got -3, -1. -3, -1, it will be somewhere here. Okay, so basically these are the 3 graphs that we have. Now to just illustrate what are they going to look like. So this one is going in that direction. Okay, this one is going in this direction. Okay, this one is like it's going also in, this one is going in this direction. So the graphs are going in different directions. So basically these are the graphs that we have. 3 functions operating, coming from one function. Okay, so this is how we solve piecewise functions. In this video, we're going to talk about the remainder theorem. Now, to understand more about the remainder theorem, you can watch our videos on polynomials. You're going to find this topic being explained. However, in this session, we're just going to be solving questions specifically on the remainder theorem. So the first question is, we're told to find the remainder when this equation or this polynomial is divided by x plus 2. So how are we going to solve this one? So since we've been told that we're dividing by x plus 2, so what you are supposed to now do is that you equate this to be 0. Since you've equated to be 0, x therefore now be equals to, I will take the 2 on the other side, it's going to become negative 2. Okay, so what this means is that in the polynomial itself, wherever there is x, we're going to be replacing negative 2. So our polynomial is 5, so I'm going to have 5 plus 6. Where there is x, I'm going to put negative 2 plus 7. Where there is x, I'm going to put negative 2. This will be squared, minus where there is x, I'm going to put negative 2 to the power 3. Then I solve. What I'm going to get is what we call the remainder. So in this case, I'm going to have 5 plus 6 multiplied by negative 2, that is a negative 12. Okay, so I'm going to put negative 12 here, plus 7. 2 squared, negative 2 squared, that is a 4, minus negative 2 to the power 3, that is negative 8. Okay, now that we've got this, I'm going to have 5 minus 12 plus 7 multiplied by 4, that is a 28, plus 8. Okay, because the negative and the negative are going to give me a positive. Okay, this is what we have for now. So what are we now supposed to do? So 5 minus 12, is that a negative 8? Okay, then plus 8 plus 28 on the other side. Is it 5 minus 12? What does it give me? Is it negative negative 7? Yeah, negative 7 actually. Then plus 8 plus 28. Okay, sorry, I'm not using a calculator. So negative 7 plus 8, that will give me a positive 1, plus 28. Then 1 plus 28, that will give us a 29. Okay, so basically that is going to be the remainder for this polynomial. So just to also remind you on the remainder, if let's say I'm dividing 7 divided by, let's say 2, that will give me 3, remainder 1 over 2. Okay, basically this is what we are looking for, the remainder. So what this means is that you've gotten this function, this polynomial, then you've divided by this. However, you've found what you found as the dividend, what you found as the answer is called the quotient after you've divided. But now that remainder that has remained is what we're trying to find. Okay, so that's how we solve the first one. Now the second one, it is 6x to the power 3 plus 7x squared minus 15x plus 4. This is divisible by 8 plus by x minus 1. So it's the same, we're not going to change from our approach. X minus 1 will be equals to 0, therefore x is equals to the 1. When the negative 1 goes on the other side, becomes positive 1. Wherever there is x, we're going to be placing by 1. So this will be 6, 1 to the power 3 plus 7, 1 squared minus 15, 1 plus 4. Then we solve. What we get, that's our remainder. So 6 multiplied by 1 to the power 3 is just 6, plus 7 multiplied by 1 squared, that is 7, minus 15 multiplied by 1 is just 15, plus 4. Then we solve this. 6 plus 7, what does it give us? That is a 13 minus 15 plus 4. 13 minus 15, that gives us a negative 2 plus 4. So what are we going to have? Negative 2 plus 4, that will give us a 2. The 2 in this case, that is our remainder. Okay, so that's how we find the remainder. Let's solve these last set of questions just for practice. So we're also going to do the sum. This equation, this polynomial is divided by that. So I'm going to get, we're saying 2x minus 1. That is the dividend. That's the one that we're dividing the polynomial into. So basically I'm going to equate it to be 0. So 2x will be equals to, when the negative 1 goes to the other side, it becomes a positive 1. Then for me to remain with my x, I'm going to divide by 2 on both sides. Therefore my x will now be equals to half. So that is what we have. Now in the equation, wherever there is x, I'm going to be replacing by half, or 1 over 2. So I'm going to have 8 1 over 2 to the power 3 minus 10 1 over 2 squared plus 7 1 over 2 plus 3. Then we solve. So I'm going to have 8. Now the 3 there just means that we are putting it on 1. It will be 1 to the power 3 and 2 to the power 3. So now 1 to the power 3, that is the 1. 2 to the power 3, that is 8. Minus, I'm going to have 10. Then that we have a square there. 1 squared is 1. 2 squared is a 4. Plus 7 multiplied by half. I can solve this one in advance. I'm going to have 7 over 2 plus 3. Then now that I'm here, what I'm now going to do is that 8 into 8, that is a 1. 8 into 8 is also a 1. So they've divided. Here I'm just going to remain with a 1. Minus, I'm going to reduce again this one. 2 into 10. So I have 1 minus 2 into 10. 2 into 10, that is a 5. Okay. Then 2 into 4, that is a 2. Plus 7 over 2 plus 3. Okay, so that is what I have. Now allow me to just wrap this part and solve this fraction into a single fraction. So we've got 1 minus 5 over 2 plus 7 over 2 plus 3. So here I'm going to put over 1, even the other side over 1. Then I'm going to find the common denominator. So the common denominator is a 2. So I'm going to have a 2 here. Now a 1 into 2, that is a 2. And a 2 multiplied by the 1, that will give me a 2. Minus a 2 into 2, that is a 1. 1 multiplied by the 5 on top, I'm going to have a 5 plus. This will also give me a 1. A 1 multiplied by the 7 on top, that will be a 7 plus. A 1 into 2, that is a 2. A 2 multiplied by the 3 on top, that is a 6. Okay, then I solve. So over 2, 2 minus 5, that is that is a negative 3. Negative 3 plus 7 plus 6. So negative 3 plus 7, that gives us a 4 plus 6 over 2. So this is going to give us 4 plus 6, that is a 10 over 2. 10 divided by 2, that is a 5. So the remainder for this one is a 5. So let's solve the last question, which is our D there. So we've got the divisor to be 3x plus 2. So I'm going to equate it to be equals to 0. When I solve that, I'm going to have 3x is equals to, I'm going to take the 2 to the other side. It will become negative 2. Then I'm going to divide by 3 on both sides. Therefore now my x will be equals to negative 2 over 3. So that is our x. Wherever there is x, we're going to be replacing just that. So I've got 9. X, I'm going to put negative 2 over 3. This is to the power 3 plus 4. Okay, pretty much that. Then what do we now do? We're just supposed to solve. So I have a 9, then negative, we're going to have a negative there. 2 to the power 3. What is 2 to the power 3? 2 to the power 3, that is an 8. Over 3 to the power 3, that is a 27. Plus 4. Then from here, we're just supposed to solve. Now, 9 into 9, that is a 1. 9 into 27, I think that is a 3. So negative 8 over 3 plus a 4. So we have a negative 8 over 3 plus a 4. If I find the common denominator, is equals to 3. 3 into 3, that is a 1. 1 multiplied by negative 8, that will give us negative 8. Then plus 1 into 3 is 3. 3 multiplied by 4, that is a 12. Okay. Therefore, what are we now going to have? Negative 8 plus 12, that will give us a 4 over 3. So that is going to be our remainder. So basically, this is how we find the remainder of a polynomial. In this video, we're going to factorize polynomials, basically the factor theorem. So to achieve this, we're going to solve some questions. Now, before we even solve these questions, a number is a factor if it doesn't leave a remainder. For example, if I've got 4 divided by 2, the only answer that I'm going to have is a 2. There is no remainder. Remainder, I mean, let's say 7 divided by 2. 2 is not going to divide into 7 exactly. Okay, it's going to give us a quotient of 3 and the remainder of 1. It means in this case 2 is not a factor of 7, but 2 is a factor of 4 because it goes into 4 without leaving a remainder. So basically that. Now, how do we factorize each of these polynomials? In this case, we are trying to find all the possible factors that can divide into this polynomial without leaving any remainder. Mind you, this is to the power 3, so that it means that we're going to have 3 possible factors. However, when we go further, we're going to solve also these kind of questions which are going to have 4 types of factors, okay, or 4 factors that can go into that expression. So let's start with this one. Now, for us to achieve this one, we're going to start trying numbers. So you can pick from negative 1, let's say negative 2, negative 1, 0, positive 1 and positive 2. Mostly start with positive 1, go to positive 2, then now go to negative 2 and negative 3. These are the common ones, okay? So now, how do we solve this one? So let's first try to look for the first factor that you can put. Let's try 1. If I put 1 in my equation here, wherever there's x, if we replace 1 and we solve, are we going to get the answer as 0? Okay? So we're going to have 6, 1 to the power 3, which is just a 1. Okay, minus 5. Wherever there's x, we're just going to have 1s there, and wherever, if you put 1s, you're just going to have those actual numbers. 6 minus 5, that gives us a 1. Minus 7 plus a 6. 1 minus 7, that gives us a negative 16 plus 6. So I'm just going to have a negative 10. Now this is not equals to 0, so it means 1 is not a factor. Okay, let's go to 2. So if I say wherever there's x, we replace now 2. So I'm going to have 6, 2 to the power 3 minus 5, 2 squared minus 17, 2 plus 6. Then we solve. Now 6, 2 to the power 3, that is 8, minus 5, 2 squared, that is a 4, minus 7 multiplied by 2. Okay, 2 multiplied by 7, that is a 14. 2 multiplied by 2 by 1, that is a 2, plus 1, that is a 3. I have a 34 plus 6. Then 6 multiplied by 8. Okay, is that a 48? Minus 5, that is a 20, minus 34 plus 6. Okay, now that we are here, 48 minus 20, that is 28 minus 34 plus 6. Okay, 28 minus 34, that gives us a negative 6 plus 6. Negative 6 plus 6, that gives us a 0. Okay, so we're able to see that 2 is a factor. 2 can divide into this expression because it's giving us a 0. Okay, this whole expression is giving us a 0. So in this case, one of the factors is x minus 2. Because you remember, when you're finding the remainder, you always get a factor, and if they've given you this is the factor, you equate it to 0. So it will be x minus 2 will be equals to 0, x will be equals to 2. Okay, then it's the 2 that you're going to replace in the whole expression. Okay, so x minus 2 is one of the factors. Okay, so let's write it now. So we found that x minus 2 is one of the factors. Then you write, now that we found that, we can find another factor. So how are we going to find another factor? We're going to use what we call synthetic division. So if I'm going to draw something like this, okay, basically something like that. Let me just make it a bit bigger like that. Okay, okay. Now we found that 2 is a factor, so I'm going to put my 2 there. Then I'm going to get all the coefficients of x in this. I'm going to get all the coefficients in this expression that I have. Okay, that is the expression that I have. So I have a 6, I'm going to put it there. I have a negative 5, I'm going to put it there. I have a negative 17, I'm going to put it there. I have a 6, I'm going to put it there. Now always make sure that you put them in what we call descending order, starting from the highest to the lowest, based on the powers. Okay, this is x to the power 3, this is x to the power 2, this is x, then this is a constant. So make sure that they're always following like that. So in case if there's a gap here, make sure that you just put a 0 there. Okay, that's what we mean. Now using synthetic division, I'm going to drop the 6. Okay, so I'm going to drop the 6, so my 6 will be here. Then what I'm going to do now is I'm going to multiply 2 multiplied by 6. That will give me a 12. I'm going to write the 12 underneath negative 5. Then again I'm going to add negative 5 plus 7. That will give me negative 5 plus 12. That will give me a 7. Then a 2 multiplied by a 7 will give me a 14. Then negative 7 plus 14, that will give me a negative 3. Then a 2 multiplied by a negative 3, that will give me a negative 6. Then negative 6 plus 6 minus 6, that will give me a 0. Every time you have a 0 here, that just tells you that that is a factor. That's why we're saying x minus 2 is a factor. Now what I'm now going to do is, since we found that these are the answers now, I'm going to drop the powers of x by one figure because we've already found one of the factors. So it was x to the power 3, now it will be x to the power 2. So what I'm now going to have is, so I'm going to have 6, I'm going to put x squared now, plus 7x minus 3. That is what I'm going to have after I've divided. So I'm going to write it here, 6x squared plus 7x minus 3. Okay, so we found another factor. Okay, so another factor for this whole expression is what we've just written here, this one. So we found 2 factors, we are remaining with the last ones. So the way we can find the last one, we are going to again break this one down, okay, because even from there we can get another factor. So how are we going to do this? So this is 6x squared plus 7x minus 3. We're going to use the aspect of what we call the product, the sum, and the factor method, if it can work. The product is 6 multiplied by negative 3. That gives us a negative 18. The factors is the coefficient of x in that case will be 37. We're going to look for two numbers. When we multiply them, they're going to give us negative 18, but when we add them, they give us a 9. They give us a 7. So that is a 9 and negative 2. Okay, they're able to achieve that. So now I'm going to say 6x squared. I'm going to say plus 9x minus 2x minus 3. So I've replaced these factors where there is the sum there, or 7x. Now when we have this, I can factorize the 3x. So I'm going to have 3x. Now 3 into 6, that is a 2. So I'm going to remain with a 2x there. Okay, plus 3x into 9x, that is it a 2? No, is it a 3? Yeah, a 3, like that. Then on the other side, I'm going to factorize the negative, so I'm going to have negative 1. Then I'm going to have 2x plus a 3. Okay, that is what I'm going to have. Then, since these ones are the same, the ones in the bracket, I'm just going to get one of them. Then I'm going to have 3x minus 1 and 2x plus 3. So you're able to see that we've broken down this to this. Okay, so basically those are the other factors that we're going to have. So overall, the factors that we have for this one, we've got x minus 2, we've got 3x minus 1 and 2x plus 3. These are the final factors for question A. So that's how we find the factors of a polynomial. Now let's solve B. B, we have x to the power 3 minus 1. Okay, this is very much predictable. A number that you can put here to give us a 0. Okay, now you know that if I put 1 to the power 3, that will just give me a 1 minus 1, which will give 1 minus 1, that will give us a 0. So we're able to see that 1 is already a factor. Okay, so because 1 is a factor, therefore one of the factors that we're going to have is x minus 1. Okay, now since x minus 1, we're saying x minus 1 because if we equate this one to be 0, that will be x is equals to 1. Okay, then x equals to 1. When you place 1 in the equation, 1 to the power 3 is 1 minus this 1, is going to give us 0. So 1 is a factor. Okay, pretty much that. Then to find other factors, like the previous one, we're going to use synthetic division. Okay, like that. Okay, so we have 1, and I'm now going to get the coefficient of x in descending order, starting from the highest to the lowest. Now, like I earlier said, you make sure that they are following each other. Here we've got x to the power 3. Let the powers of x also reduce. So this can also be written as x to the power 3. I can even put 0x to the power 2. I can put plus 0x minus 1. You're able to see that the values of x are reducing from 3 to 2 to 1. However, even if I've put these zeros, they are not even adding up to anything. All you just want is to have a complete order. Okay, so even in that case, I'm going to put those powers to be reducing. So the first one, it is, in this case, the coefficient of x in this case is what? See, okay, let me just, okay, it's the coefficient of x in this case is what? It is a 1, so I'm going to put a 1 there. Then what follows is a 0, another one is a 0, then we have a negative 1. That's what I was just showing you. Then now to solve synthetic division, I'm going to drop this one and I'm going to have a 1 there. Then I'm going to multiply 1 multiplied by 1, that will give me a 1. A 0 plus a 1, that will give me a 1. A 1 multiplied by 1, that is a 1. 0 plus 1, that is a 1. 1 multiplied by 1, it is a 1. Negative 1 plus 1, that will give us a 0. Every time you have a 0 here, just know that 1, that is part of the remainder. Then the powers of x are going to drop. Here we had x to the power 3. Now I'm going to have x squared plus x plus 1. Okay, so that is what I'm going to have. Now what will be our equations here? I'm going to have x minus 1 and x squared plus x plus 1. So basically those are our equations. Then are there any factors that we can look for this one? Let's try. What is the product? Excuse, the product is 1. What is this the sum? It is a 1. Factors, numbers, when you multiply them, they're going to give us 1. When you add them, they're going to give us, basically the product and the sum method can't work. However, these are the two solutions that we're going to have, unless if there are any other solutions that you can find apart from these ones. But these are the ones that we can find as far as this question is concerned. Okay, however, if you want other expressions, solve this. Okay, probably maybe using completing the square is going to give you the other roots. Basically that. Now let's solve these other ones. So these are to the power 4. So here we have to be very careful. So let's look for a number that if we replace it here, it's going to give us a 0. So let's start with 1. 6 to the power, so 1 to the power 4. So wherever there is 1, I'm just going to have 1 there. So it is 6 to the power 4. 6 multiplied by x to the power 4. X is 1. 1 to the power 4 is just 1. 1 multiplied by 6 is 6. So I'm going to have 6 plus 31 plus 57 plus 44 plus 12. What am I going to now have? 6 plus 31, that is a 37, plus 57 plus 44 plus 12. So you're able to see that these, all of them are adding up. So there is no chance that I'm going to get anything like a 0, because all of them are adding up. So meaning 1 is not a factor. I don't even have to go as far as much as solving. What if we try negative 1? Its counterpart, negative 1 to the power 4 plus 31, negative 1 to the power 3 plus 57, negative 1 squared plus 44, negative 1 plus 12. Okay, now that we got that, let's solve. Negative 1 to the power 4, that is just a 1. Okay, so I'm going to remain with 6 here, plus. Then, negative 1 to the power 3, I'm going to have a negative 1. So basically, I'm going to have negative 31 now. Plus 57. Negative 1 squared, that is just a 1. Okay. Then minus 44. Well, minus because of the negative that we have there. Then plus a 12. Okay, at least here we have got negatives, so we can solve. We see what it will give us. 6 minus 31, that is going to give us what? Is it negative 25 plus 57 minus 44 plus 12. Now negative 25 plus 57, what are we going to have? We're literally subtracting. So if I've got 57 and 25 and as I subtract, that is a 2. That is a 2 there. Then this is a 3. Okay, so I have a 32. So I'm going to have a 32 there. Minus 44 plus 12. Then 32 minus 44. So if it's 44, 32 there, we subtract 4 minus 2, that is a 2. 4 minus 3, that is a 12. Okay, so I'm going to have a negative negative 12 plus 12. So able to see that this is giving me a 0. So negative 1 is a factor. So since negative 1 is a factor, we found one of our factors. So therefore, I'm now going to write x plus 1. Okay, why x plus 1? Because if we say x plus 1 is equals to 0, x will be equals to negative 1, and when we place negative 1 into the actual equation, that's when we are getting 0. So x plus 1 is one of the factors. What about the other factors? Okay, so now here, that's where we go back to synthetic division. At least we found that 1 is one of the factors, so it's going to help us find other factors. Okay, so since this one has got different, I'm going to put a lot of them there. Okay, so now let's start. We have negative 1. What are our coefficients from this function? We've got 6. Okay, so I'm going to put them just the way they are flowing. So we're starting from 6, we're going to 31, we're going to 57, 44, and 12. Okay, so to solve this one, I'm going to drop the 6. Since I've dropped the 6, then the negative 1 is going to multiply by the 6. I'm going to have negative 6. Then 31 minus 6, that will give me a 25. Then negative 1 multiplied by 25, that will give me a negative 2. Negative 1 multiplied by 25 is a negative 25. Then 57 minus 25, that will give me a 32. The negative 1 multiplied by 32, that is a negative 32. Then 44 minus 32, that is a 12. The negative 1 multiplied by 12, that is a negative 12. Then 12 minus 12, that is a 0. So we're able to see that 1 is a factor. Now since 1 is a factor, I'm going to now drop the powers of x. Now in this case, I'm going to have 6x to the power 3 plus 25x squared plus 32x plus 12. Okay, so that is one of the expressions that we have. So we have x plus 1 and this expression there. Okay, now that we've got that expression, so from this expression again, we're supposed to look for a number that if we put, we're going to get a 0. Okay, so in this case, let's try again. So allow us just to wrap this part. Okay, so let's look for a number. If we put 1 here, 1, 1, and 1, all of them are going to give us positive numbers, right? And when we're adding positive numbers, we won't get a 0 there. So 1 can't be one of the, we've already found that 1 is there. Then let's try like a 2. If we put a 2 there, what are we going to have? Okay, since if we put a 2, these will just be bigger numbers. Okay, so we're able to see that if we put numbers that are positive, we're going to get bigger numbers, which can't give us 1. So we're going to target negatives. Let's try negative 2. If I've got 6, negative 2 to the power 3 plus 25, negative 2 to the power 3, squared now, plus 32, negative 2 plus 12. Now that we've got this, I've got 6, then negative 2 to the power 3, that is 8, negative 8 actually, then plus 25 2 squared, that is a 4, plus 32. I can okay, 32, negative 2 there, plus 12. Then we solve. 6 multiplied by negative 8, that is negative 48, plus 25 multiplied by 4, that is 100, plus 32 multiplied by 2, that will give us a negative what? That is negative 64, plus 12. Okay, now that we've got this, let's now solve. From 100 we remove a 48. What are we going to have? That is okay, that is a 9 there, that is a 10, that is a 2, that is a 5. So we're going to have a 52. Okay, so we have a 52 minus 64 plus 12. Now 52 minus 64. 64 minus 52, what are we going to have? That is a 2, that is a 1. So able to see that we have a negative 12. Okay, so negative 12 plus 12. Negative 12 plus 12, that is a 0. So we're able to see that negative 2 is one of the factors. Okay, you see the factor in this equation that we've just wrote, the one that we're just from finding. So here now I'm going to write negative. So x, in this case, another factor that we're going to have is x plus 2. Okay, then we've got an expression. What other expression are we going to now have? Since this is the one that we're just from getting, let's solve it using synthetic division to find other factors. So I'm going to have a 2 there, I'm going to have a negative 2 there, then I'm going to get the coefficients from this equation. So I've got a 6, I've got a 25, I've got a 32, and I've got a 12. Now that I've got that, the 6 is going to drop. Then I'm going to now multiply negative 2 multiplied by 6, that will give me a negative 12. Then 12 minus 25 minus 12, that is a 13. Negative 2 multiplied by 13, that will give me a negative 26. Then 32 minus 26, that is a 6. Is it? Yeah, that is a 6. Then negative 2 multiplied by 6, that is a negative 12. Then 12 minus 12, that is a 0. Okay, so we've got another 0. So basically now the powers of x are now going to drop. This time around it was x to the power 3. Now we're going to have x to the power 2. So in this case, the other equation that we're going to now have is 6x to the power 2 plus 13x plus 6. Okay, so I'm going to write it here, 6x squared plus 13x plus 6. Okay, now we've reached like 3 answers. At least we are now remaining with the last ones. So how are we going to now find the last ones? We are going to get this same last equation that we're just from finding and break it down into 2. How? Let's try the product, the sum, and the factor method. The product for this equation, 6 multiplied by 6, that is a 36. Then the sum, it is just the coefficient of x in this case, which is 13. We're looking for 2 numbers. When we multiply them, they're going to give us 36, but when we add them, they're going to give us a 13. Okay, so what are those 2 numbers? So from our equation, 6x squared plus 13x plus 6, we're going to have 6x squared plus 9x plus 4x plus 6. Therefore now when I factorize on both sides, I'm going to have for this one, if 3 is a common one, so I'm going to have 3x. Therefore here I'm going to have 2x plus 3x into 9x, that is 3x, that is 3. okay, plus I'm going to, for this one I'm going to get 2 as my common, so I'm going to have 2x here plus a 3, yeah, like that. Then I'm going to have 3x plus 2, then I'm going to have 2x plus a 3. Okay, basically those are the answers. So the factors for this equation, we have x plus 1, which is this one. We have x plus 2, and we have these ones that we're just from finding, 3x plus 2, 2x plus 3. So those are our factors there, like that. There are 4 of them. So basically that's how we find the factors when you're given 4 when you're given to the power 4. If you're given to the power 5, it means you're going to have 5 factors. Okay, so basically that's how you solve this one. Then to the power 4, x to the power 4. Okay, this one we're just going to do it quickly. X to the power 4 minus 11x to the power 2 plus 28. Okay, 2 numbers, or let's say what is going to be a factor in this case. So if I pick a 2 here and I square it, I'm going to have 16 here minus 11 multiplied by 2 squared, that is a 4, plus 28. So that is 16 minus 11 multiplied by 4, that is a 44, plus 28. Okay, then 16 minus 44, what does that give me? If I've got a 44 and I've got a 16, 4 minus 6, okay, let me say this is a 3, 14 minus 6, that is 8, 3 minus 1, that is a 2. Okay, so I about to have a negative 28 plus 28. That will give me a 0. So 2 is one of the factors. So since 2 is one of the factors, I'm going to have 2, or I'm going to have x plus 2, or x minus 2 actually. Then I'm going to now do synthetic division to find as the, so x to the power 4, the coefficient of x to the power 4 is 1. Then what is going to come now? So here it's supposed to have 0x to the power 3, so you have to consider that when you're writing. So in this case I'm going to put a 0. Then now I'm going to put the one that follows, which is the coefficient of x squared, which is negative 11. Then I'm supposed to have 0 to the power x, because the powers are supposed to be reducing. So I'm going to put a 0. Then I'm going to put the last number, which is 28. That's the descending order that we've been talking about. Now I'm going to drop the 1. Then I'm going to multiply 2 multiplied by the 1. That is going to give us negative. That is going to give us, actually this is negative 2. Okay, so negative 2, what am I doing? This is 2 actually. 2 multiplied by 1, that is a 2. Then 0 plus 2, that is a 2. 2 multiplied by 2, that is a 4. Negative 11 plus 4, that is a negative 7. 2 multiplied by the negative 7, I'm going to have negative 14. Negative 14 plus 0, that is a 0. That is a negative 14. Then 2 multiplied by the negative 14, I'm going to have negative 28. Then 28 minus 28, that is a 0. Okay, then what am I going to do? The powers of x are going to drop. In this case it was x to the power 4. Now I'm going to have x to the power 3. So this will be x to the power 3 plus 2x squared minus 7x minus 14. Okay, this is what I'm going to write here. I'm going to have x to the power 3 plus 2x squared minus 7x minus 14. Okay, that is what we have. Now we're also going to look for a number that we're going to put there so that it gives us a 0. Okay, in this case, okay, if we put 2 here, that would be a very big number. 2 here will be a very big number. It can be compared with this. This is 2, that is like 14. Okay, basically this is going to be 2 can't agree. It's going to give us a bigger number than 0. Let's try its opposite. If I put a negative 2 there, negative 2 here, negative 2 there, negative 2 there, what are we going to have? Okay, it's like negatives, they are always achieving it. So let's say x to the power 3. In this case, I'm going to say negative 2 to the power 3 plus 2 negative 2 squared minus 7 negative 2 minus 14. So now what are we going to have? Negative 2 to the power 3, what does it give us? So it's going to give us negative 8, then plus, then negative 2 squared, that is a 4. A 4 multiplied by 2, that is 8. Then negative 7 multiplied by negative 2, that is a plus 14. Okay, then minus 14. So able to see that negative 8 minus negative 8, negative 8 plus 8, that is a 0, plus 14 minus 14, that is a 0. So negative 2 is also one of the factors. Okay, so another factor that we have, this one we had the 2, which is x minus 2. Now this time around we're going to have a negative 2. So we're going to have the factor that we have x minus 2, x plus 2. Okay, so now from the previous equation, I'm now going to get the coefficients to find by synthetic division. This is 1, this is 2, this is negative 7, this is negative 14. Okay, I'm going to drop the 1. Negative 2 into negative 2 multiplied by multiplied by 1, I'm going to have negative 2. 2 minus 2, that is a 0. Negative 2 multiplied by 0, that is a 0. Negative 7 plus 0, that is negative 7. Negative 2 multiplied by negative 7, that will give us a 14. A 14 minus negative 14 minus 14, that is a 0. Okay, so now the powers of x are going to drop. I'm going to have, since it was x to the power 3, now I'm going to have x squared. So it will be x squared minus, actually I'm supposed to put 0x, so I'm just going to put it in advance. 0x minus 7. Okay, or I'm just supposed to put x squared minus 7. So therefore now our factors, they've increased. So we've put x squared minus 7. Why I'm not putting the 0x doesn't carry anything there. Okay, basically this. Now what are the other roots that we're going to have? So we're supposed to solve this quadratic. Now we have x squared minus 7 is equals to 0. Okay, how do you find the value of x? So in this case, x squared will be equals to 7. For you to find the values of x, you're going to square root on both sides. So x is equals to positive or minus the square root of 7. Okay, so those are the values of x. So in this case, if these are the values of x, what do we know? So if x is equals to, so x is equals to positive the square root of 7, and the other one x is equals to negative the square root of 7. So I'm going to take them back the way they were. So I'm going to have x, this is going to change, it's going to be minus the square root of 7. Okay, that is equals to 0. Then the other one, it is x is equals to x plus 7, x plus the root of 7 is equals to 0 as well. I've changed them. So basically those are part of the equation that we have. So the four answers for this one, we have x minus 2, x plus 2, x minus the square root of 7, x plus the square root of 7. So those are the final answers for this polynomial. So that's how we solve a polynomial which is raised to the power 4. Okay, basically that, not complicated. So thank you, and we're going to see you in other sessions. In this video we're going to talk about synthetic division. Basically this is just a segment of polynomials. Now to achieve this, we're going to use some questions to just familiarize ourselves with how we solve questions on synthetic division. So the first question asks us to use synthetic division to not only find the quotient but also the remainder when we divide by that factor. Okay, so now I've said that factor, but we're not sure if it's a factor because it's only a factor when it doesn't give us any remainder. Okay, but if it gives us a remainder, it's not a factor. So let's start with the first one. We're saying x is minus 2, that is our divisor. If we're going to equate this to be equals to 0, x will be equals to 2. Okay, so since x is equals to 2, in our equation, wherever there is x, we're going to be replacing by 2. Okay, and if we replace by 2, we're going to find the remainder. However, that is the remainder theorem. Now we're not going to use the remainder theorem. Let's use synthetic division. Okay, so I've said that because you can use different methods to solve this same kind of equation. So we've got x to the power 4. Always make sure that the powers of x are reducing. Okay, so able to see x to the power 4, x to the power 3, x to the power 2, x to the power 1, x to the power 0. Okay, they are reducing like that. So in this case, since we're saying x is equals to 2, so I'm going to put my 2 here. I'm now going to get all the coefficients of x. So the first one, it is 1. For x to the power 3, it is negative 2. For x squared, it is negative 3. For x, it's negative 4. Then the last one, it is negative 8. Okay, now that I've got this, what do I now do? I'm now supposed to just now put, I'm going to drop the 1, then I'm going to multiply 2 multiplied by 1, that is a 2. Okay, the negative 2 plus the 2 will give me a 0. Then 2 multiplied by 0, that is a 0. Then negative 3 plus 0, that is a negative 3. 2 multiplied by the negative 3, that will give me a negative 6. Then negative 4 minus 6, that will give me a negative 10. Then the 2 multiplied by the negative 10, I'm just going to have a negative 20. Okay, a negative 20. Then negative 8 minus 20, that will give me a minus 28. Okay, so basically that is what we have. Now that we've done this, what this now means is that I'm now going to reduce the powers of x. It was x to the power 4, but the fact that we found one of the factors is going to now drop. Okay, so I'm going to have x to the power 3 now. Then I'm going to put a 0, x to the power 2. Then I'm going to put x, okay, I'm going to put negative 3x, so I'm going to plus. So here I'm just going to put negative 3x. Then I'm going to have my negative 10. Then I'm not going to put my negative 20 because the negative 20 is negative 28, that is the remainder. Okay, so basically what is the quotient? We've been asked to find the quotient and the remainder. So the quotient is what we have just written. This is the quotient, the answer that you get after you divide. Then the remainder is this one. So this is our remainder. Okay, so basically this is how we solve this question. So we're also going to do the same for this question. So we're going to use synthetic division. So I'm going to get the divisor, which is x minus 3. I'm going to equate it to 0. X will be equals to 3. Okay, so since x is equals to 3, I'll use the synthetic division like that. Okay, now that we've got that, I'm going to put my 3 here. Then I'm going to get the coefficients of x. In this case, I've got 1, I've got 3, I've got negative 2, and I've got negative 5. Then the power 1 is going to drop. Then I'm going to say 3 multiplied by 1. Okay, that will give me a 3. Then 3 plus 3, that is a 6. 3 multiplied by 6, that will give us an 18. Okay, then an 18. Then negative 2 plus 18, that will give us a 16. Then a 3 multiplied by 16, that will give us 48. Okay, the negative 5 plus 48, that is a 43. Okay, so this is the remainder. Now what are we now going to finally have? The quotient will now be equals to, now the powers of x were at the power 3, now they're going to drop. So I'm going to have x squared plus 6x plus 16. Then the remainder for this function is just 43. So basically this is how we solve using synthetic division. In this video, we're going to apply functions in real life problems. How you maximize profit of a business, how you can fence around using functions. So basically, let's start. Now the first question is that we're told to suppose that the equation is this, where x represents the number of the items that are being sold, let's say from this business. Then it describes the profit function for a certain business. How many items should be sold to maximize the profit? Now watch the key terms here. You want maximum profit from what you are selling. So because you want maximum profit, functions, anything that relates with functions, we're talking about now the maximum of the function. That's at that point where you're going to find the maximum profit. For example, if this is our graph, if it goes like this, okay, the maximum is at the turning point. Okay, so if it's at this point, it's at this point that you're going to have the most profit. Okay, so for example, if let's say this is 2, this is, let's say, 8. Okay, you're able to see that 2 is on a lower side, 8 it was on a higher side, and at 8 we're having the highest value of x and the highest value of y at that 8. So able to see at 8 we're going to have a lot of profit. Okay, that's where now the functions come in. So now for this question, we don't really need to solve a lot. So we're supposing that that is a function. So we only find the value of x at the maximum for us to find the profit. So how do we find the maximum, the value of x at the maximum? X is equals to negative b over 2a. Now from this, our a is equals to the coefficient of a, which is negative 2, okay, which is the coefficient of x squared in that regard. Then our b in this case, it is the coefficient of x, which is 280, and our c is equals to negative 1000. Okay, we're just putting the c with, although we're not going to use it. So negative, our b, it is 280 over 2 multiplied by our a, which is negative 2. So basically this is what we have. Then we're just supposed to solve. So I'm going to have negative 280 over the 2 multiplied by the negative 2. I'm going to have a negative 4. Then I'm supposed to divide. So the negative and the negative can divide, which will just give me a positive. Then a 4 into 4, that is a 1. A 4 into 28, that is 7. Then there's a 0 there, 70. So what this tells us is that the number of items sold is 70 for us to reach to a very maximum profit. Okay, so for this business, for us to maximize the profit, the number of items that should be sold for X, they should be like 70. So basically that. Now we have another question. A man with 180 meters of fencing wishes to fence off an area in the shape of a rectangle. What should be the dimensions of the area if the enclosed space is to be as large as possible? Now imagine this. Let's say this is a rectangle. Okay, that is our rectangle. Now you know that a rectangle in this case is going to have the perimeter and the area. So if we're going to choose sides, let's say the shorter side, let's say this is y, and the longer side, let's say this is x. The perimeter, it means you're adding all the sides. So this will be y and this will be x. So for us to find the perimeter, the distance around this shape, that would be x plus y plus y. That would be the perimeter. Now note what we've been given. We've been given that this, the one that you're fencing, is 180 meters. So I'm going to say this is equals to 180 meters. Then I'm supposed to solve so that I find out what equation I have. Now x plus x, that is a 2x. Then y plus y, that is a 2y. This is equals to 180 meters. Now what I'm now going to do is that I can factorize the 2. When I factorize the 2, I'm going to have 2x plus y is equals to 180 meters. I'm going to ignore the units for now. Now that I've got this, I can divide by 2 on both sides. I'm going to have x plus y is equals to 180 divided by 2, or 2 into 2, that is 1. 2 into 18, that is 9. That would be 90. So x plus y is equals to 90. And if I want, I can make any of them to be the subject of the formula. So this is for the perimeter. But how are we going to find the area for the rectangle? You know that the area for a rectangle, it is just the shorter side multiplied by the longer side. In this case, that is x and y. Okay, if that is x and y, from this our equation, we can make any of them to be the subject of the formula. Okay, so in this case, let me choose to make which one to be the subject of the formula. Let me choose to make y the subject of the formula. Okay, y will be equals to 90 minus x. Okay, since y is equals to this, I'm going to replace it there. Okay, so our area is equals to x, our y is 90 minus x, so that I find the value of x. Okay, so in this case, I'm going to have our area to be equals to x multiplied by 90, that is 90x. X multiplied by x, that would be x squared. Okay, that is the equation that we have. Now, what do we know about the value of x at the maximum? Because they've asked us to find as large as possible. So therefore, talking about the maximum there. So because we're talking about the maximum here, we're going to find the value of x at the maximum. The value of x at the maximum is x is equals to negative b over 2a. Negative. Then what is the function? The function that we're just from finding, we're saying a is equals to 90x minus x squared. If I'm going to write it as a standard function, this is the same as negative x squared plus 90x. That is the function that we've found as a area. Okay, now what is our b and what is our a? Our a in this case is a coefficient of x squared. In this case it is a negative. Okay, so I'm going to have, then our b is a coefficient of x, which is 90, so I'm going to have negative 90 over 2. Our a was saying is negative 1, so negative 90 over 2 multiplied by negative 1, that is a negative 2. So when I divide negative 90 divided by negative 2, that will give me a 45. Okay, so we found the value of x. Now you must remember, we said, so if x is equals to 45, what about y? Okay, so this is our equation that we had found. Y is equals to 90 minus x. So therefore our y will be equals to 90 minus x. We found that it is 45, so x minus 90 minus 45. Y will also be equals to 45. Okay, so basically those are the values of x and y. However, we haven't been asked to find the values of x and y. They will just now help us to find the area. Okay, and the area in this case we said it is x multiplied by y. In this case x we found that it is 45, and y we've also found that it is 45. Then basically we're just supposed to multiply the two. Here that's where I use my calculator. Okay, so 45 multiplied by 45, I'm getting 2025. So in this is going to be meter squared. So basically this is how this should be the dimension of the area. If it should be enclosed as large as possible. Okay, x should be 45 and y should be 45. So basically that's how we apply functions in some of day-to-day activities.